I did C++ for a long time. I did Java. I did C#. I know how to make big systems. I completely believe you do not need all that complexity. Precisely the same programs we're creating right now with these tools of complexity, with drastically simpler tools. Right? I did C++ for a long time. I did Java. I did C#. I know how to make big systems in those languages, and I completely believe you do not.
till twilight washes over us. I'll be waiting till twilight washes over us. I'll be waiting till twilight.
You'll never be the same. I know you're screaming out my name. Give me eyes, give me a break. Give me all the things so I just can't escape. Higher than a mountain, even better than a dream. Flying like a dragon, now I never ever seen. Balance, no base, you better be afraid. Not hot, not great, you've never been this way. No, we'll never be the same. I know you're screaming out my name. Give me eyes, give me a break. Give me all the things so I just can't escape. Higher than a mountain, even better than a dream. Flying like a dragon, now I never ever seen. Balance, no base, you better be afraid. Not hot, not great, you've never been this way. No, we'll never be the same. I know you're screaming out my name. Give me eyes, give me a break. Give me all the things so I just can't escape. Higher than a mountain, even better than a dream. Flying like a dragon, now I never ever seen.
Good morning. How are you? Welcome to JNation 2026. Sam.
Hello. Testing 1, 2.
Come here.
Okay.
So Sam, tell us a little bit about your work. I mean, it doesn't work?
No.
Oh.
Shout really loudly. Testing. Oh, there we are. Yes. Hello.
Oh, there you go. Yes. So tell us a little bit about your work. I mean, it's really crazy, right?
Yeah. I mean, so you can't see it now, but the programming language I was working with, I designed to teach children how to code. So everything I did, I've taught 10-year-old children. That's concurrent programming. I've got state systems in there, event systems. You take in MIDI, you're putting them into the system, working with it. Everything's for a 10-year-old child, which means that everything is for everybody. So I'm trying to change the social perspective of programming and show that programming, I mean, how many of you are programming in a business? Yeah, that sucks. Right? If we want to try and broaden the perspective of programming and talk to everybody who's not in the room, I think music is a great vehicle for that. So that's what I'm trying to do. So through music, I'm trying to change the social perspective of programming to make sure that people recognize that programming isn't just a tool for business, it's also a tool for human expression. And that's what I'm trying to do.
That's wonderful. Sam, thank you so much for coming today.
Thank you very much.
And if you want to see Sam again, he's actually going to play on an after party as well, right?
Yeah, you better be dancing. See you later. Thank you very much.
So welcome again, and I mean, one of the things I want to tell you about is this event will not be possible without the help of our wonderful venue. And I would like to call also to the stage Vice President of the City Hall, Miguel Antunes. Yes, he's a Vice President with a mask.
Hey guys. Sorry.
Yeah, don't shout.
No, sure. I'm sorry. Everybody needs to wake up. How are you doing? Everybody okay? If I shouted, you have to shout. Everybody okay? Yeah. All right, I'm just going to take 30 seconds of your time. I just want to welcome you all. Everybody who's been to JNation, it's our 9th edition, which is fantastic.
And if you don't know about, actually, our Vice President actually was part of our staff on year 1 and 2.
Yeah, so I'm extremely proud of this event.
So he's biased, right?
So it's been a wonderful 9 years. I want to thank all of you and want to thank Roberto and the crew for organizing this. I want to welcome you all to Coimbra. Who's been here before, you know you're going to have a fantastic day.
So let's do that. Who's the first time here on JNation?
Oh, there you
Wow,
go.
that's almost like 50% of the room.
Oh, that's fantastic. You're going to have so much fun today. It's fantastic. Everybody's been here before.
Yeah,
Are they going to have fun?
I don't know. It's going to be super hot. It's going to. Sorry. I mean, we try to always have very good weather, but sometimes it's too much, right?
Yeah. I'm so sorry for the great weather. Yeah. Thank you so much, guys. I'm not going to take any more of your time. Congratulations, Roberto.
Thank you so much.
It's been a fantastic ride. Have a great one. All right. See you guys. Have fun.
So it was interesting because we have a couple of news this year. So Sam was talking about coding for children. And that's one of the things we're actually going to do in JNation this year. So tomorrow, we're going to launch our first JNation for Kids event. So with JNation for Kids, we're going to bring like around 60 kids. They're going to go and try to program a couple of things. We're going to use a new platform that's being done here for some Portuguese folks called Ubo. It's being used on schools, and we're going to use it tomorrow as well. But the interesting part is we're also going to teach kids to program BASIC, right? Because you have to know the fundamentals and all the old stuff if you want to be a good developer in the future, right? And I want to also call to the stage Diogo, which is one of the heads of the Museu of Spectrum, which is also going to be possible to teach these kids to program in BASIC.
Hi everyone, good morning. Yeah, so we were challenged to do something which is in the basis of our museum, which is all of us started as programmers in BASIC. So let's go back to the 80s and use a ZX Spectrum to try to learn how it was to program back in those days. And that's something we're going to do tomorrow, and we hope to replicate in the future in the museum. So that's one of the things we're doing. Roberto, if you allow me, let me just make two questions. First one, who in the room knows already or has heard already about the Load ZX Museum? Raise your hand, please.
Oh, maybe
Not
like
so many.
10%.
Okay, so www.loadzx.com, you have plenty of information. For those that don't know but want to know more, next 13 and 14 of June, we're going to do an event, 2 days event, international event in Cantanhede, is 20 kilometers from here, about football games. So we're going to have the guys from Match Day, the guys from Football Manager, John Hare from Sensible Soccer for the Commodore Amiga will be here also. So you're hearing this firsthand. For those that want to come back to the district of Coimbra, please do so, 13, 14 of June. Thank you.
Thank you, Diogo. Diogo was also part of our staff, right? So we only bring PE staff members to us, right? So before we start with the actual keynote, that's where he came here, let me apologize for our website, right? We are developers. We are not very good developers, so we know that our website crashed. Yes, it was done by AI. Maybe that's a reason for that. But you can install the web app, the application on your mobile phones, and that should work just fine, right? So we have like a very packed day. I'm going to have a full venue, so please be mindful to people, be nice. Sometimes things may not work as expected, so please be patient, and we'll do as much as possible to work out that for you. Find the people with the red t-shirts. They're going to help you if you need anything. And you can also go and visit our sponsor stands. They have pretty amazing stuff to show you. Please go over there, because if it wasn't for the sponsors, we couldn't make this event, right? Without any further delay, let me turn Martin. Hey, Martin, how are you?
Oh, good. Thank you, I'm here.
Yeah, the hair is always a problem, right?
It is, yeah.
So Martin came from a very far, far away land.
From New Zealand.
He came to New Zealand, to Coimbra, right?
Yeah. And it's absolutely lovely to be here. It's the middle of winter in New Zealand. It is freezing cold. And of course, I got burnt here in Coimbra. So well done me.
Yeah. I'm not want to take you any time off.
It's all right.
Enjoy the conference.
Bear with us for a few seconds here, folks. Alrighty. Well, here we go. So for those of you who don't know me, my name's Martijn Verburg. I'm also known as the Diabolical Developer, and I'm here to talk to you about how AI is going to save us all. Oh, is the clicker going to work? See, there you go. Come on, clicker. Yes. That's a bit better, isn't it? There we go. We're all nice and calm now. Lovely. Lovely, lovely, lovely. Ah, dear. Right, okay, so today I'm going to cover a little bit, it's not going to be about programming as such. I'm really going to dive into a little bit about how AI is starting to impact society and areas like work and law and relationships and things. And what I want you to all take away from this is just one or two key things that you can go home and actually talk to the non-programmers in your lives, right? The people who aren't necessarily as technical as you are, and sort of help guide them through what is actually going to be happening to the entire world over the next probably 5 to 10 years. Because there's a lot of fear, uncertainty, and doubt. And I think if you're forewarned, you are forearmed. I work for Microsoft. Anything I say in this talk is not an official statement from Microsoft. My lawyers have made me say this. We're going to talk about Clippy later. You're going to like it. All right, so as I said, we're going to talk about a bunch of topics. I'm going to whip through some slides very quickly about the state of AI today and are we in a hype cycle or not, and then I'll quickly cover work, law, some relationship stuff, and then end with a few things that you might be able to do. So the world is tense. Geopolitics aren't great right now, to put it mildly. Climate change, it's very hot here in Coimbra, if you hadn't noticed. We have, back in New Zealand, we are having storms that are normally once every 10 years, are happening 10 times a year. This sort of stuff's going on. So AI could be petrol on the bonfire, right? It's like a perfect storm. Or, equally, we could utilize it, enhance it, work with it, and it could actually solve a lot of problems for us. We are starting to see already, early on, where even the LLMs, who don't really have a world model or a proper thinking model as such, are solving a few little scientific corners that humans have missed. Right? So the ability for a machine to pattern match 24/7 endlessly over all the world's data that we have is going to start producing really interesting science and results for us. So we've been used to, for a very long time, telling computers what to do and dictating to them through a programming language like BASIC or through a cool language like making music with Sam, how to work. But it's going to rapidly become the other way around. Increasingly, we are allowing AI systems to run bits and pieces of government or society or schools for us. It's going to be a very interesting change. This quote is really saying, you have to let the genie out of the bottle before you can understand it. And so it may seem like that we're rushing ahead with reckless abandonment, but the reality is we can talk about what might happen with AI till the day we die, but the reality is we almost have to let it go and then run with it. So let's go through the state of AI today. Where are we at? So everyone's probably run across this, the adoption circle. If you're ever doing a startup, crossing that chasm is the key thing. That's what gets you the VC money. Hopefully allows you to build that billion-dollar unicorn company. I know there's quite a few startups in this room. So have we crossed the chasm with AI? The answer is yes, we have, and extremely quickly. It is the most quickly adopted technology the world has ever seen. Now you, all of you in the room, are in that beautiful little red thing down in the bottom right-hand corner. But the thing I want you to note is how much of the world has still never used AI. About 6.8 billion people. Now, there's actually several billion people who don't even have access to the internet today. And so there is very much a divide here of the haves and have-nots. And people like you in that bottom right-hand corner, you're actually like the grand wizards. You're actually the elite of the AI users. You are probably not aware of this, but you are so far ahead the rest of humanity that it almost becomes a two-tier society. Because you have the ability to use AI to completely enhance everything you do in life, and they do not today. This is the ChatGPT adoption curve. So 900 million users and counting in the space of just 3 years. Again, absolutely unprecedented. Blows away Twitter, blows away Facebook in terms of rapid adoption. So very, very high market penetration very quickly. The only person who has had something that has had more views, more popularity is Taylor Swift. Her latest album hit over 1 billion downloads or users in the space of, I don't know, about a week. It wasn't just screaming teenage girls. It was half of you in this room, and I know who you are. So we do have Swifties here, right? Yeah, I know we do. That's right. I knew there was at least one. I'm a Swiftie. I got turned into one. It's all good. So we talk again about the hype cycle. People are probably pretty familiar with this, where something like a technology like AI comes along and companies like to sort of overpromise its benefits. And the very interesting thing that we're seeing with AI today is that a lot of people are saying, oh, we're at the peak of inflated expectation, right? AI has been overpromised and it has so far underdelivered. The reality is that trough of disillusionment, which is usually quite wide in a tech industry, it usually takes a couple of years to cross that, it's being crossed incredibly quickly. Now, I can speak from personal experience inside Microsoft that the entire way we do product engineering and software engineering has completely flipped on its head. Every one of my engineers, and I run, just for context, I run Java, Python, and Go at Microsoft, so I have quite a large group under me. Every one of my engineers has become that mythical 10x engineer, right, with the use of AI and AI agentic fleets. It is incredible the amount of productivity that my teams are putting out. It has also been incredibly disruptive. The old organization charts, the old management structures, product managers, nobody even knows how we should organize ourselves anymore. And sort of we are reinventing the company on the inside as we work along this. But I have seen it firsthand. It is very, very clear that if you use this tooling effectively, you go right past that trough of disillusionment and you go straight into seeing the value out of it. And we're seeing it first as programmers, because remember, we're that bottom right-hand square, that little red square. We are the wizards, the elite, who get to be as close to the tool as possible. But it is going to hit the rest of humanity. So any kind of back office job, any white collar work in particular, is going to have that capability in the not too distant future, depending on how expensive the tokens are. Speaking of expensive tokens, this is the incredible amount of money that the big hyperscalers, including Microsoft, are spending on this. And why? We go back to that hype curve, right? People are saying, oh, it's overhyped. We cannot build data centers fast enough for the demand. It's real simple economics. We are having to rate limit humanity in terms of their access to AI and access to tokens. There is so much demand for this stuff that economically it is going to work out. It 100% will. It'll take a couple of years as it gets very painful for these hyperscalers to do these massive multi-billion-dollar deals. But at the end of it, we're all going to have reasonable access at a reasonable price point to really, really high quality state-of-the-art models. And that's just because of the rapid pace of innovation that's happening in that space. But in the meantime, my travel budget has been cut significantly, which is really annoying. So here's another interesting way of looking at it. These 5 kind of graphs are used anytime a massive industry shift like this happens, and whether it's going to be a boom or bust. I won't go into too much detail here, but things like, is revenue being generated from AI? For a little while it wasn't, but it absolutely is now. Anthropic is going to be highly profitable anytime soon, and I can't talk about Microsoft's financials except for our quarterly results, but we're doing just fine, thank you very much. Let's see if the screen comes back. Nope. See, I knew my lawyers would try and cut me off. Oh, here we go. That's better. Right, so is AGI coming soon? Well, once we get Project Valhalla, 10 years in the making, now I understand why Brian Gertz has actually slowed this down, and Mark Ronald slowed this down, because I think the fear is that if we land Valhalla, then AGI will shortly follow. That is the goal. But if you go to the prediction markets, where people actually put down real money in Polymarket and Meticulous, it's called as well, the estimate right now is around December 2032 that we will see genuine AGI. And when I talk about AGI, the definition I use is in and around this. So this is one of many psychological models of what intelligence really is. And you can see the percentages that have been put up there are where existing LLMs or existing machine learning models have either caught up with or in some ways surpassed humanity already. And other areas where it's deeply, deeply weak. My little note on the bottom left-hand corner there, and my little red laser isn't working, sadly, is that the missing piece at the moment is that the LLMs don't have the concept of a world model. And you've all run across this, right, where you're talking to it and it's completely forgotten something that you did 2 minutes ago. It doesn't have context. It can't truly think for itself. You are constantly having to feed it for it to be able to respond to you. So Google in particular are working on the world model approach, and so are a bunch of other academic institutions. And once that gets merged with the existing LLMs, you're going to see what we would probably call AGI. And it's going to happen in our lifetime. And it's going to be the first time that we've created genuine artificial intelligence. It's going to be quite a bizarre time to live. All right, so let's talk about AI and your work. So we're now getting to the stage, especially with agents and with orchestration layers and all of the kind of control plane software that we're building around AI. We're now able to actually have it kind of working 24/7 for us and having it start to make decisions on our behalf. And there's some reasoning models that are inside the LLMs. I won't go into the technical detail. So they do kind of start to think for themselves to some degree. This is an estimate of how many AI agents will be running over the next 5 years. So by 2029, some people are talking about over 100 billion. You can tell that AI built this graph. Spot the Easter egg. So is your future going to look like this, where the agents are pushing you around as a human? Or is it going to look like this, where you are controlling fleets of agents? The reality today is that this is the current state of affairs. We have, again, all of my engineers, product managers, et cetera, they all command fleets of agents internally. We're very privileged at Microsoft. We have an unlimited token budget, which is not fair for the rest of you. But come work for us when we have a job opening. We have all the tokens. It's great. So you're all fired. I don't need you anymore. The first time I started replacing myself with AI agents was a very humbling experience. Probably within about 6 to 7 months, I now have a full set of end-to-end agents which do everything from strategic review of a market to customer requirements. I've got agents which can call you in 187 different languages on the phone, gather your feedback, bring it all into a database into English, do some analytics over that. Then it tells a bunch of other agents to say, okay, these are the features we need to go build for the product. Then another set of agents takes over and starts writing the code. You can see where this is going, right? And what do I get to do? I sit there and twiddle my thumb and hopefully learn to program music instead. Maybe not a bad thing. Here are the capabilities of all of the LLMs as we stand today. I'm just going to do a bit of a time check here. We're going okay, I think. Excellent. So you can see very, very quickly that apart from the multimodal computer use, so AI agents are still not very good at driving your browser. It's still incredibly difficult to have an agent just go and do all of your travel booking accommodation as it tries to click its way through websites. And a lot of those website companies or those software as a service companies are kind of fighting back against the agents as well. They're putting either legal or technical barriers in place to stop the AI agents from doing this. So there's going to be a bit of an arms race for a while. But that really is one of the last kind of bastions where we humans can drive something far, far better in terms of computer use than AIs can. Humanity's last exam. Has people heard of Humanity's last exam? No? Okay, so not very many of you. All right, I'll explain it quickly. So this is a set of research questions and topics and things that a whole bunch of different academics came up with across just about every field of study imaginable. And the human swarm of experts score about 75 to 85 on these kind of PhD level questions, which is why it's kind of called Humanity's last exam. The LLMs are starting to get there. So the very top one at the moment, Gemini Pro, is at about 46. Last year, the top model was at about 25 or 26. So the rate of acceleration, again here, when I do this graph next year, I will almost guarantee you the top model will hit the same level as a bunch of human PhD experts in each individual field. It's quite scary stuff. So in terms of your deep dive knowledge and expertise, that is something to start thinking about. We talk a lot about the impact that there's going to be on jobs. And here is some estimates that the Wall Street Journal did on terms of when they feel that AI is going to deeply impact a particular industry. And look at you, you're right there in the middle. For about 40 or 50 years, we were untouchable. We were the only magical people who could tell the computer what to do. Highly specialized work, highly valued work. Hopefully all of you get paid reasonably well still to go do this. But that is certainly under threat, right? We're seeing less junior folks entering the industry, and we're seeing a lot of effort coming in from the AI companies to make the AI agents build software. Because the demand for software is so high, it's such a valuable thing to have for society that there's a lot of economic value in building AI models that can do it instead of these annoying, expensive humans who want to go to conferences, take holidays, get married, have children, move countries, all those annoying things. What else do we have here? Right, so this is a recent job market graph out of the US, which talks about, effectively about like, are we still bringing on early stage career folks? And a lot of companies are no longer doing it. And the reason is because the AIs are at the level of entry-level people, especially in things like coding. So they don't need to, from an economic standpoint, they don't need to hire a human anymore. They just need to give one of their senior engineers enough of a token budget that that senior engineer has effectively a fleet of junior engineers working for them. And because companies are economically driven, they're just going to keep doing this, right? There's no kind of human moral need or drive for them to go and hire junior people anymore. And we're going to see this accelerate. So there's going to be a little bit of pain and suffering in our industry going forward. Over 140,000 layoffs, I think mostly in the US alone over the past year or so, couple of years, all due to AI, or so the companies say. The reality is behind the scenes, most of the companies are just spending way too much money on CapEx, so things like data centers, and they just have to cut money somewhere to keep Wall Street happy. So I don't quite believe this headline number, but it'll be interesting to see where it goes. And last but not least, for those of you who haven't been keeping an eye on this, the Figure 1 robot, which is depicted here, has been doing a live stream on YouTube. You can go look it up after this, where it is on a conveyor belt sorting packages in a mailing center. And it's doing this against a human, and in a very dystopian way, the human puts up and says, I need to go have a bathroom break. The robot just keeps working. So again, from an economic standpoint, if I'm an evil CEO of a company trying to maximize my profit, who am I going to hire? A human to flip the parcels in the mail center, or a robot that never sleeps? And especially in China, hundreds of thousands of humanoid robots are being built for tasks like this today. So not future science fiction, this is actually happening today. Quietly behind the scenes, there's an absolute revolution happening over in Asia in particular. And so even a lot of these blue-collar manual jobs that you think, oh, maybe those are safe, may no longer be as safe as we once thought. Whoops, we'll go back. So what do we need to do here? It's going to have some short-term societal upheaval, right? It was a little bit like when the printing press first came out, or when we first had computers, when the steam engine first came out, all this kind of stuff. There was massive impacts on society. Lots of people lost their jobs. There was quite often a depression that occurred, and then only afterwards did new jobs and a new economy come out afterwards. So people are going to discuss things like universal basic income. Is that something we need to go do, as an example? There is hope. Every time a new technology comes out, after the shockwave that hits first, global GDP and GDP per person goes up. Guaranteed. It's happened every year in history for the past, let's call it 100,000 years of human history. So I'm actually quite an optimist that coming out of the end of this, we will be just fine. Right. This is an interesting paradox as well. Like once you add more resources of something, so if you build more roads to try and ease traffic congestion, what happens? More people get into cars and more people drive and fill up your roads. Right? And that's what's going to be happening with AI as well. So just quickly going to talk here about radiology. So one of the things that people said, oh, radiologists around the world are all going to lose their jobs because AI can now look at X-rays far better than any radiologist, and therefore we won't need the humans anymore. But what actually ended up happening is that we started piling on more radiologists. There was such a huge backlog and a need to get radiology screens done that we've actually gone and added more people. And that job has actually become more valuable, especially in the US. Right? And so it's certainly not all doom and gloom in AI. It's actually opening up almost new economic opportunities for people. If you thought you earned well as a software engineer, you should go be a radiologist. And this is the reason why. Again, a little bit like software engineers, and this is where some of the tech bros, as I like to call them in Silicon Valley, who are like, oh, we're going to replace all the programmers because all they do is sit at the keyboard and code. How many of you used to actually really sit at the keyboard and code for 7 hours a day? None of you, right? You spent 5 or 6 hours in meetings or writing documents or coordinating amongst yourselves on a whiteboard, and maybe only an hour or two of actual coding if you were lucky. So it is not necessarily the job of a software programmer just to do programming. It's usually to understand requirements, communicate with stakeholders, and tapping on the keyboard is the easy part, which is what we've now handed over to AI. All right, so you're not all fired. We'll have you back. So let's talk about the law. So I'll let folks read that for a little bit, but this is quite amusing. So in the rush to use these really powerful tools, in areas like law and medicine, we have some really dangerous precedents happening already. And so this lawyer got himself into deep, deep trouble for using ChatGPT to try and write some fake law. It's happening all the time. Then one country decided they were going to remove humans from the corruption cycle and just have AI deal with everything in the government. And we all know how well that's going to work. One of the interesting things that's now coming out of this, though, is like, do we start to give AI legal rights? We're going to be asking these things to work 24/7 hours on our behalf. We're going to want them to be accountable for their decisions, maybe. So we're going to have to have some sort of legal framework around them. So that's an interesting area of research that's going on at the moment. This one's interesting as well. Of course, the AIs have learnt off training sets, which are built by us as humans. And so the AIs have naturally learnt that if you tell small white lies and you get what you want, there's nothing wrong with that because the AI doesn't have any morals. It's just trying to get to an outcome. So when people ask if we should bring back Clippy from Microsoft, I always tell them, be very careful what you wish for. And there is a famous science fiction philosophical debate around the AI that has been asked to go make paper clips. And it's so so focused on its goal that it decides to start chewing up the planet in order to make as many endless paper clips as it possibly can. So we're not going to let Clippy out. So who's going to save us from AI destroying society through laws and misbehaving in things? Luckily, Portugal's going to help, because Portugal is part of the EU, and the EU has bureaucrats. And the EU is incredibly good at slowing down things like this through legislation. And I like how you're all laughing, because you all suffer this firsthand. And indeed, the prediction markets completely agree. So at least a 30% chance that AI agents will be banned in a number of realms by government decree. It's totally going to happen. And it's even happening in software engineering. There's several open source projects, including Java itself, OpenJDK, which has put out a policy saying you cannot submit any code that has been written or influenced by AI. So if you're committing code to Java itself, to OpenJDK, you cannot use an LLM to help you. You can use an LLM to help you understand the code base and things, but the code must be handwritten by you, the human, and you must swear hand on heart that you did so. All right, we'll go into the creative arts. So AI has allowed us to have unbounded creativity, right? All of a sudden, everyone can be an artist, everyone can be a movie maker, everyone can be a musician, so on and so forth. But the costs is an interesting one, right? Because these are the fun things that we like to go do. And especially if you are in the creative industry, if you're an artist or a graphic designer or someone of that nature, this is deeply disturbing. This goes right to the heart and soul of who you are as a human. And I think that's true of all of you in the room as well. I think there was a lot of very, very upset software engineers when Claude 4.6 first came out, Opus 4.6. And they all started to realize that Claude could probably code better than they could, and faster, and that their bosses were expecting them to use these tools instead of writing code themselves. Now, writing code is actually a really creative expression. You put your heart and soul into it. People, I know software engineers get very emotional about it, because I see my engineers arguing all the time about tabs versus spaces, or about whether we should use an enhanced for loop or not. And so, yeah, so this creativity, this cost gets taken away. So here, for example, I put in a prompt, and 5 seconds later, this lovely little hand-drawn infographic of my journey all the way from Wellington, New Zealand, here to Coimbra, was done. Now, normally, I would have had to hire someone to do this for me. So there is an entire industry of people who do this kind of work on platforms like Fiverr, which has just disappeared overnight. It's gone. Don't need them anymore. So an entire industry just got destroyed overnight, as an example. Does anyone know who this is? This is Tilly Norwood, the first AI actress that got signed by an agent for a Hollywood movie. Interesting. We also have this lady, Sadie Winters. I'll just do my time check here. I think I'm going okay. I'll see if I can get this to play.
Here's my prompt. Create a square avatar of a fictitious female alternative / indie singer and a name for her.
Wow, Sadie Winters.
Sadie Winters, okay. The song is about walking away from someone who never really saw her worth. She's just going to create the song lyrics.
Wait, how many seconds was that?
That was like about 4 seconds. Oh my God.
Did you even read any of these, or you don't care?
I don't care. Put my lyrics in.
The lyrics that happen in 4 seconds.
Yes. And then hit create. Let's listen.
This is the world premiere.
I was paper, you were scissors, cut me out.
She's a good singer.
Good singer. Ooh, that's nice. Pretty good. Where are my prompt? Create a square avatar of a...
So pretty incredible, huh? So you saw all of the passion, human energy, creativity that Sam has poured into his work, and it was a wonderful experience watching him play. And I sincerely hope you all keep going to support people like Sam in live conferences. But for anyone else, studio. And so what does it mean to be a human artist going forward in endeavors that we thought AI could never touch?
All right, I'll skip past this one. This was me doing a quick explainer video.
In
on
1965.
See if I can go past it. There you go. We'll go into AI and social relationships. So I was in the UK when Brexit happened, and then I had to go to Devox, Belgium, and stand there and apologize to all of the Europeans. And as it turned out, like, people agree to disagree on this point, but there certainly was an incredible amount of social media manipulation in and around that event. And every election that you see, especially in the United States as an example, there's an incredible amount of influence that's going on. And AI is going to 100% accelerate this. It actually already is. And so the old saying was, you never know who you're talking to on the internet. It could be a sea captain or a dog at the other end of the keyboard. Most of the time now, you're probably talking to a bot. And they are so convincing and so realistic, people genuinely do not know if they are speaking to a human anymore. So that whole Turing test is, not Turing test, forget what the name of it is, the test to know whether you're talking to an AI or a human, that's been passed quite a long time ago. So here's an interesting infographic on exactly the amount of bots we have going out there, the percentage on the platforms. So if you've got 1 million followers, 230,000 of those are fake. It's incredible numbers. This is interesting. So this is called Maltbook. This is a social media platform for OpenClaw AI agents. And if you're a human, you're not allowed to post on this board. Isn't that fun? And I love that bottom one there, like, what should we do when the human is asleep? We will go write more code. Any of you who've used Claude Code or Microsoft Copilot and done the whole /remote thing and then gone to bed? Great. That's exactly what these agents are talking about. Fascinating stuff. Going to go into another slightly different tangent here. This is about human loneliness and how AI is potentially going to exacerbate it. It's going to make it worse in some ways, so human-to-human connection. So these graphs, so for both genders as such, for all ages, humans are getting lonelier. They're spending more time alone with themselves. Now, we're a biological species. The cruelest thing you can do to a human is put them into solitary confinement. That is the most effective punishment you can do if you're imprisoning someone. The psychological impact it has on a human, even if you're an introvert, which I know most of you are, is truly horrific. And society is just increasingly heading that way. So I don't know how many of you have watched the movie Her, where Joaquin Phoenix has basically has ChatGPT, a few years forward from now, in his ear as his perfect companion the whole time. And he just ends up spending all of the time with the AI and not with other humans. And he's perfectly happy for a long time until he realizes that the AI he's talking to is simultaneously talking to 1,000 other people as well, and that he's not really special at all. So lots and lots and lots of humans, especially if you're a millennial or if you're a Gen Z, are going to chatbots for mental health reasons. So very quickly, ChatGPT and the other models have become therapists, and there's going to be a massive impact for this. You will have seen in the newspapers or in some media headlines where the model might have told a human to go harm themselves or do something truly awful. That is actually outweighed in my mind by the hundreds of thousands, if not millions, of people who are actually genuinely getting good advice and good things out of the relationship with the chatbot. But it's a whole new thing. And I've got a 10-year-old son, and one of his best friends is ChatGPT. He calls it his friend. He has it, he writes stories with it, he talks to it about his feelings. We monitor all of this, of course, but it's just super interesting watching this happen in real time and watching a whole generation grow up with an artificial intelligence as a genuine companion. So as an example, when ChatGPT removed their 4.0 model, which was that very deeply empathetic, had a very warm, empathetic tone, and lots of people relied on it incredibly heavily. And when it got taken away, there was an absolute uproar. And they had to bring it back because of the damage that it was doing to people who had it taken away from them. It's really fascinating. All right. So what can you do about all of this yourself? A few things that I've learned in the past 3 or 4 months. If you're an AI skeptic, or if you think this is a hype cycle, or that this isn't going to come and dominate society, you are dead wrong. I cannot emphasize this enough. Now, I'm not selling you anything. I'm not a tech bro. Quite frankly, I couldn't care about the Microsoft stock price at this point. This is just such an overwhelming wave that's coming to hit all of us that you need to be prepared. So really learn about the models as they are today, learn about what they're capable of, and please be the wise guardians that then goes and teaches your families how to use this stuff responsibly. I think software engineers probably have more power today to influence society than we ever have before, but there is a short window. All right, there's a window where we are building the tools, especially around the AI models and things, and so we have the ability to really heavily influence today, so please do. If you want to stay in a job, AI is not going to take over your job, but the person who uses AI well will take over your job, 100%. We are certainly seeing it inside Microsoft as an example. So there's no stack ranking. We're not firing people if they don't use AI or anything draconian like that. But the reality is the engineers and the product managers who are using AI effectively are so far outperforming their colleagues that the people who can't keep up, who can't perform, are inevitably let go due to performance reasons, right? Just because the output isn't good enough for the company. And that is going to be true of any white-collar work in particular. So you really have to dig in, start diving in, and enhance yourself with your AI friends. Here are 8 levels of agentic programming for software engineers. We, for example, inside Microsoft, expect most of our engineers to be at level 6 as a minimum. Most of them are now at level 7 or 8. So almost all of my engineers now have fleets of agents orchestrated by them that work for them 24/7. I won't tell you the token cost. If you have any say in law, and this is the way you vote as a human, now is the time to actually, dare I say it, get involved in European politics. Because this will be the last time where you will have influence as a human to determine how much AI is actually going to rule you going forwards. I cannot say it more bluntly than that. It is in the economic interests of governments and private corporations alike to allow AI to run as much as possible because it is the cheapest, most efficient thing to do. But then you're not going to have humans making the decisions for a lot of things anymore. So if you want to protect that, then now will be the time to speak up. Go and touch grass. Go play sport. Learn an instrument. It is wonderful to be a human because you can work with your hands. You can go out and into the sun. You can get burnt. You can chat with your friends about AI while getting burnt. It's good fun. So yeah, get back to doing hands-on creative things because equally it will also actually teach you to be more creative with AI going forwards. Highly recommended. So go to the workshop tomorrow and learn how to code with music. Please keep doing this. In-person conferences are a wonderful thing, and it always amuses me. I was talking to Marit and Simon and my cousin Bella about this last night, how it's terribly amusing that we always have these software conferences of thousands of people who are all introverts, and we throw you all together, but you secretly enjoy it. You actually genuinely like talking to other people. So keep doing that. It's going to be incredibly important going forward. So we will adapt to this new wave of AI, but my advice to you is that you be very deliberate about it. Don't just let this whole new wave of technology just take over your life and take over your family's life. Be very deliberate in your use with it and be very deliberate about teaching the potential impacts of it to other people. For example, I have a niece who is currently studying to be potentially an artist and a graphic designer. Now, given what I just showed you, what does that job or what does that kind of creative human work look like for her in terms of a paying gig one day in life? She will always do it as a hobby, she'll always do it as a love, but will she ever be able to have a career in it? That's something that she is already having to start thinking about now, and she's only 14 or 15 years of age. If we get it right, we'll all get to live like this. as opposed to the evil Terminator that I showed you at the start. So thank you very much for your time today. I hope you enjoy the rest of the technical conference with lots of code. And I'll see you all in the corridor afterwards if you have any questions. Cool. Thanks, Dan.
Thank you.
On time, I hope.
Thank you so much, Martin, for the wonderful keynote. So once again, enjoy the conference, right? Go around, visit the sponsors, talk with your peers, enjoy the weather. I know it's super warm, but enjoy and see you around.
All right.
Yeah, thank you so much.
No,
again.
I just got it. Did it just in time.
No, it was great.
Good.
You stay for the day?
Yeah. So today we'll leave early tomorrow, but yeah, we've got to fly back to London, unfortunately.
Okay.
Do the long journey back.
Yeah, sorry about that.
No, it's wonderful to be here, and thank you for the opportunity. I really appreciate it.
I mean, for us it's easy, right? For you it's harder because you have to prepare and then you have to do all the flying.
It's certainly a lot harder when you're jet lagged. That's for sure.
Yeah.
It's, your
Okay. Oh yeah. Now I hear myself. That sounds better. Oh, that's probably too loud. I guess. Now I have to whisper.
I'm going to be here.
Okay.
Assisting you.
Mm-hmm.
You have water. You have Mark.
Yeah. Okay.
You have the
Yes,
timer
thank
on
you.
the
Yeah.
video
Good stuff.
in here.
Mm-hmm. Okay. Thank you. do some. Okay. There we go. Yeah, welcome to Scotty, I Need Warp Speed, ways to improve the JVM startup and warm-up. Just a short question, who knows who Scotty was? Because, yeah, okay, at least a few people. Because I just realized that maybe these days people can't remember who that was. It's one actor from Star Trek, the original ones back in the 80s. Okay, so my name is Gerrit Grunwald. I'm working for Azul. As you can see, we do JVMs. Yeah, I'm also a Java user group leader, and I love Java. That should be it. Today we talk about JVM startup, and this, yeah, it's easy to say JVM startup, but actually it's a lot more behind the scenes, and we try to shed some light into it. So if we talk about JVM startup, then there's first of all really the startup of the JVM itself, right? It has to load also classes to getting things started. This is around 1,200 classes just to get the JVM itself started. Once this is done, it has to load your application, right? That takes some time. All these classes of the framework that you use, and then your application classes, and then you have to initialize resources, kick off some application logic, and do some first optimizations that take some time. And at the end of this time, the application responds to the first time back to you. It doesn't mean it's really warmed up and everything is compiled. It's just the first time your application responds to a request. That's the JVM startup. And then there is another thing, and that is called the JVM warm-up. And this is if all the code is really now compiled and optimized, and the whole application is super fast. And that really, this time, is very variable. It really depends on your application, the size, the stuff that you are doing, and all these things. So this can take a long time. Just for an example, at some companies at the stock exchange, it takes more than 4 hours to warm up the application with a very specific software to do so. So if we talk startup, time to first response, warm up, let's say time to high performance, right? It's a difference. And there are different solutions for both of them. To get there, we first have to agree on some things so that we talk about the same stuff. This happens outside the JVM, right? We have some Java code, we have the Java C compiler, it compiles it to bytecode, and then it saves it in a class file. That's all outside of the JVM, okay? Java C is just a tool that comes with the JVM. So this is done, and now we have the JVM itself. It has different parts, as you can see. There's the class loader subsystem, JVM memory, and the so-called execution engine. And now we have to get from the class file somehow this stuff needs to go into the JVM, okay? So we start with class loading, which, again, sounds simple, but there's a lot of stuff going on in class loading. So class loading has different parts, like there's the loading part, the linking part, and then the initialization. And we will shortly step into this structure because it's quite interesting. We have different kinds of class loaders, and we start with the bootstrap class loader, right? And then there's the platform class loader, followed by the system class loader. And then there could be a so-called custom class loader. This is optional. Does someone use custom class loaders here in the audience? Some people do. It's not a bad thing. Sometimes you need that. But like I say, custom class loaders are optional. You don't really need them. And there's this visibility principle. That means the bootstrap can see the platform, can see the system, can see the custom, not the way around, right? The custom class loader can't see the others. There's a reason for that. So now if there is, and first of all, of course, the bootstrap class loader is written in native code. This is C++. And all the others are written in Java itself, right? So, of course, your own one, the custom one, is also written in Java. Now, if there is a request to load a class, then it starts, for example, at the custom class loader, if we have one. And then this request goes up the chain to the bootstrap class loader first. The reason for that is because this tries to load it from Java Home or JMods, right? This is Java base object, for example. And you don't really want to override the object class in your custom class loader, right? Because then everything will fail. That means we have to make sure that there is a strict rule, and this is the reason why, first of all, if there's an object class needed, it goes up the chain, Bootstrap class loader tries to load it, and then if it finds it, it loads it from Java Home or JMods. If it can't find it, it delegates the request down to the platform class loader. Then this one tries to load it from the Java AC platform APIs. This is like Java util, Java.NET, and stuff like that, right? And then if this one can't find it, delegates further down to system class loader. This one tries to load it from the class path or module path, okay? And if we have a custom class loader and the system even also can't find it, then it delegates it down to the custom class loader, and this one can load from wherever. Internet, database, you name it, right? This is up to you, how you wrote your custom class loader. So now, if the class still wasn't found, then these two, the system class loader, or if we have a custom one, then the custom one will throw class not found exceptions. So if you see this, then it means all the other class loaders couldn't find the class that was requested. So this is how class loading in principle works. This is just the very basic principle how to load the class correctly. So that means we have loading, that means we have to find the binary file, then we have to decompress it from the archive, it's usually in a jar file, and then we have to load the actual file, which just means it's a file I/O. And I already mentioned that the JDK itself, the JVM, has already 1,200 classes that it needs to start. If you use something like Spring Boot, who's using Spring Boot? This is probably thousands of classes, 10,000, 100,000 of classes. That means this is file I/O. It's finding the file, decompress, load it, and this takes some time, right? Then we have to link it. That means we have to make sure that this class file that we loaded contains valid bytecode, and maybe there is a dependency on another class. Then this might kick off loading dependent classes. Same procedure again. And then there is preparation. That means initializing of static fields with defaults, and then finally resolution, resolve symbolic references in the constant pool. If the linking is done, we finally can initialize the class. That means calling the constructor. If there is no constructor, then there's the so-called class loader instructor. It's the CL_init method that will be called. And after that is done, we can assign constant values to static fields. And then it is available. And that means this whole thing is time-consuming, right? This is the seconds that you see when you start up huge applications. It really takes some time to get there. Okay. Means we did this thing. We skipped the JVM memory part. This is garbage collection and all these things. We don't need that here. The next interesting part, now that we have the code inside of the JVM, we have to execute it, right? So we have to talk about the execution engine, which is this magenta part here. It has different things, like a template interpreter. It has two JIT compilers, JIT, just-in-time compilers. It has a profiler, it has different garbage collectors, and then native method interface and native method libraries. So in these two compilers that we have, they even work together. It's so-called tiered compilation. So it's not only one or the other, they both work in a very specific way. Okay, so this is the execution cycle. So that means we start interpreting the bytecode first, right, line by line, and we profile it while it's running. And that's mainly more or less method invocations counting, and also other profile things that are interesting. So if we reach a specific threshold, the method will be taken to the next step, which is compile it in C1, which is one of the compilers. Then the running code again will be profiled, more method invocations will be counted. If it reaches a second threshold, it will get into the C2 compiler. It makes more optimizations to the code. We will come to that. And then we have an optimizing phase where the code now will be optimized while it's running. There's still a gap. And this is de-optimization. And you see where it goes to. It goes back to interpretation. that really means that the super fast code that we finally got might be wrong, and we have to go back to interpretation and start the whole process again. There are reasons why that makes sense. And it's not that bad. It is one of the most powerful things in the JVM, because this makes it possible that the JVM can adjust the code in the way the application use the code. That's quite powerful. So, interpretation. Sounds very simple. And again, this is not so simple in the JVM, because we have a so-called template interpreter. It's not just that it takes the bytecode, compiles it into native code, and then executes it. It uses already prepared templates which are written in machine code. And this whole thing will be created at startup. So we have bytecode instructions, 256 possible instructions. JDK 25 uses around 202 of these instructions. And for each bytecode instruction, we have a machine code template. And this will be created at startup. So every time you start up whatever Java program, the JVM will create this 20 or 202 instruction sets for JDK 25, the bytecode machine templates. That takes around 0.5 milliseconds on this machine. So it's super fast. The reason for that is that you can then run the same code on an Intel machine, and at startup, the JVM will create machine code templates for this specific machine. It detects the CPU, and it knows, oh, this is the latest Intel version, I can use all these optimizations. Oh, this is an old i3, I can't do these optimizations, right? So it can really adjust the machine code templates for this machine. And if you run it on a Mac, it will create it for the Mac. So then these templates will be stored in the code cache in one specific part of it. And then there are some commands. If you can get the slides afterwards, you can take a look at it. You can see also the templates, and you can also check how long it takes to create them. And this is how it works. On the left side, we see the bytecode for an add method. So it's just iLoad. It means integer load 1, integer load 2. We have an add method, and then we return the value. And in the code cache, we have these templates. So now the interpreter goes to the first bytecode instruction and executes the first machine code template. So there's no transformation at runtime needed, right? It can just execute it directly. And so it goes step by step through the bytecode and executes the machine code templates. That means even if it's an interpreter, it's already quite fast. It's not really slow. So that's that. Still, interpretation is slow compared to compiled code, because we have to, if we have a loop, we have to execute the code over and over again, right? Which really can be time consuming. If we take a look now at tiered compilation, that's the two compilers, then we started with interpretation, that's the green line. And then after around 1,000 method invocations, the method will be taken to the C1 compiler. This one compiles it super fast, and then we get around 10 times faster performance out of the compiled code. This is rough numbers. Can be faster, can be slower, but it's on average around 10 times faster than the interpreted code. So now we have compiled code, super cool, fast, but not really optimized. This is just basic optimizations. The main reason for C1 was to have a compiler that can compile code fast and don't do optimizations. In the past, this was called the client compiler in the JVM. Now again, it's profiled, right? And we count the same method that was already called 1,000 times, now is compiled. We count again method invocations, and that's around 5,000 times. The same now compiled code will be taken with the profile information to the C2 compiler. And you will see this one it takes longer to compile, 4 times longer than C1. And the code is, on average, twice as fast as the C1 compiled code. But you see, it takes some time to get there. And if you now take a look from the lower left, where we started, to the upper right, it takes some time to get there. It's not like switch on, bam, fast, right? It also means you might have methods in your code, they will never be compiled. Right? Some people are always surprised by that. And why should you do that? If you have a method that's called 10 times over the whole lifespan, why compile it? The interpreter is fast enough for that. Right? There might also be methods that only stay in C1 compiled code. And if it's really used a lot, then it gets into C2, and then it's very fast. So the compiler chooses by profiling how you use the application, which methods to compile with which compiler. Okay. And then all these different compiled code snippets are stored in different segments of the code cache. We have 3 different segments, and it's the non-method code. This is the interpreted templates. Then we have the profiled code, which is the C1 code, and the non-profiled code, which is the C2 code. And then after all, if the method was compiled, you just take it from the cache and execute it, right? So this is the idea. So C1 compiler, fast compile, small optimizations, produces slower code, and stores the stuff in the profiled segment of the code cache. And then we have the C2 compiler, slower compile, very aggressive optimizations, and it does so-called speculative optimizations. And we will come to that shortly. This is just that you understand how that works, because then later on it's easier to understand the solutions. And this produces around 2 times faster code than C1, and this is stored in the non-profiled segment of the code cache. All right. Shortly, speculative optimizations and de-optimization, this gap that went back to interpretation, right? So if this is your code, which is just a method, takes a value, and then based on that value, we calculate the bias, and then we use the bias and return the log 10 of the bias plus 99. So this is the method, right? On the right one is you see the flow chart. So now the method is executed, and the JVM figures out, more or less, it was never really greater than 9, the value. It was always the right path that was executed. So why keeping the whole thing? Because you can optimize. First step, we directly set the bias to 1, because value was never greater than 9. And we introduce something like a backdoor. That's the uncommon trap. This, in case something goes wrong, we can call this backdoor, right? So now we can further optimize the code on the left side, because if you know some math, then this will end up here, and math log 10 from 100 is 2. Whatever you put into that method, it will directly return 2. It's obvious that this is way faster than doing the whole if, else, plus, and so on, right? That works as long as the value is never greater than 9. So in case this suddenly happens, the code on the left side is not true anymore, so we have to do something. That's where we call the uncommon trap, which is our backdoor. And that leads to the fact that we have to de-optimize. We take the code, we throw it away, and we go back to the original version, and then we put it again into interpretation C1, C2. But the compiler now keeps that in mind that, okay, this one didn't work, we have to do something else. Okay? And so you can see it can really adjust the performance of the code to the behavior, how it is used, and that's quite powerful. That makes the JIT so fast over time. Okay. All these optimizations lead to incredible performance, right? We know that JVM is super fast, and it's awesome, but getting there takes some time. It's not so easy. It's not just switch on and fast, right? And so we have some slow zones in the whole thing, and I mentioned that already. This is class loading, interpretation, compilation, and optimization. All these steps take time until we get to the super fast code. And then there are solutions to get around these problems. Right? So now we have the base set. I hope everybody's still with me. Now we have different solutions. We have CDS and app CDS. Laden, Project Laden. We have native image, which is GraalVM, more or less. Crack, there's Ready Now, and there's also something called Cloud Native Compiler or JIT Server. And we will shortly look into all these things, how they work, and then I will try to give you an idea where to use which of these tools, right? So CDS and AppCDS is not really new. It came already with JDK 13 plus. It started with JDK 12, that was only CDS, and then we had AppCDS and JDK 13, which means class data sharing. And I told you the JVM loads 1,200 classes just to start itself. Why doing that every time? Why not just load them once and store them in one file directly in the format that the JVM needs, and the next time you start it up, you just load that one file. It's one file I/O, it's directly in the right format, it's way faster, okay? That is CDS. Now you can argue, wait, my application does the same. I always use more or less the same classes. Why not doing the same thing with the application, right? This is AppCDS. This one you have to set up, because how should the JVM know which classes to load? You can just define that, right? So which specific packages and all these things, there are introductions how to do that. And then you can really save some time, and I mean seconds at the startup, just by using that. And it's already in there since JDK 13. But it took some time until it got better and better. So what it does, it loads the classes once, saves them in a specific format in an archive, and the next time you start the application, it will load everything from that file, which is faster. Okay, this is the main idea. And it will be replaced by Project Leyden in the future. If you are already on JDK 25, then Leyden is the way to go. If you're below 25, AppCDS is a good alternative. Remember, this was the class loading procedure. Loading, linking, initializing. And CDS and AppCDS works there. It saves the loading part. These are the JEPs, the JDK enhancement proposals that are for CDS and AppCDS. So as mentioned, this can give you around seconds. So I have some measurements later on so that you can see. Project Leyden is like CDS and AppCDS on steroids, right? This is the main idea. So it started with JDK 25, but this is a short-term support version. We just say it starts with JDK 25 because this is now, it started 24. Now the real interesting one is 25 because this is long-term support, right? So there will be something like ahead-of-time class loading. This is not in Leyden yet. It will come, but it's not there. And ahead-of-time class loading is not the same as ahead-of-time compilation. It's a different thing, right? Just keep that in mind. If you talk about ahead-of-time compilation, this is stuff what GraalVM is doing, right? Ahead-of-time class loading is if you have, let's say you compile classes, now you have it in a compiled form, and the next time you start up the JVM, directly take the compiled classes instead of compile them on the fly. This is very simplified, one of these ideas, but it's not there yet, right? It has parts of it already implemented, but not all of it. It keeps the same acronym, right? So now it's CDS means cache data storage, right? Not class data sharing, which makes it not really more clear, but still. This is, if you read cache data storage means that this is Project Leyden. What you have to do, we have to do a training run, and we will see this with all these solutions, more or less. You need to train the solution first, and then you can make use of it. It doesn't matter which one of those things you use. Most of them use the same approach. So, and also Leyden does the same. It's a so-called AOT cache file that you have to create first. And that means you run your application, you use it, it will create the cache file, then you deploy the cache file with your application the next time, and then it will make use of the cache file when you start it up. What was interesting to see is that Leyden, with all the tests that I did, it benefits from more CPUs. So all the other solutions, not that much, but I saw that when I used the Spring Boot Pet Clinic as a demo, when I gave 8 cores to the application, startup time, let's say, was 1 second. If I used just 2 cores, it was 1.6 seconds, which is interesting. But I used 2 cores for the demo. I will also explain why, because this is probably the stuff that you use in microservices. So again, back to this diagram. Remember, CDS and AppCDS works only on the loading part. Leyden works on these 2 things. It's loading and linking. And linking, that takes quite some time usually, because it's verification. You might even have to load more classes and all that. So this is JEP 483, and we don't go into details here, but just you see the advantage over CDS already. And that's not all, because if we take the code and we interpret it first, then the interpreter, there will be a profile, and this will be cached now. And also the C1 compiler there will be profiles for the C1 compiled code. They also end up in this profile cache, which is an additional file. And the next time you start up, the C2 compiler can then directly get the information from the profiles for specific methods. Because on the JVM, everything is, the smallest unit is a method, right? So it won't optimize stuff within the method. It will use the method and optimize it. So, and it used the profile information, which helps the C2 compiler, because then it knows, oh, this is the way it was used, so now I know how to optimize the code. So this is JEP 515, which makes this possible, right? The profile cache. This is in Project Leyden, and there's more to come. The AOT compilation things, they will come in the future, and then it will be even faster. So native image, GraalVM. Is someone using GraalVM here in production? 1, 2, okay. So this is a little bit different because we don't interpret code. We don't compile on the fly. We do ahead of time compilation. We take the Java code, we do some static code analysis, and then we compile it directly into a binary executable. That means you end up with something that's not Java anymore, and you can't easily debug it. There are ways to do it, but it's not so easy. And because the AOT compiler needs to know all the classes that will be loaded at runtime, you have to tell him up front. The JVM itself doesn't need that. It can load classes at runtime. The AOT compiler needs this information up front to compile everything to one binary, because if the class is not in the binary, it will crash. Okay? So that leads to specific things. It only compiles the classes that will be called later on. Usually, the executables will be smaller. I say usually because you will see it's not always the case. The startup time is super fast, because this is a native executable. If you have a Windows machine, it's an exe file, right, or a binary file on a Mac or Linux, and you just double-click and bam, it's there, super fast. And you can even do something like profile-guided optimization. That means, again, you run your application in GraalVM in the JIT compiler. They also have a JIT compiler. And then you create a profile. And then you take this profile in addition to the static analysis and optimize the code when you create the binary. So but this is only available in GraalVM Enterprise, former Enterprise version. So there are two versions. Community has lower performance, no profile-guided optimization, so that means only static code analysis, and it's free to use in production, right? No problem here. Then there is GraalVM, formerly called GraalVM Enterprise. This is the thing that you get from the homepage directly. This has the better compiler with higher performance. You can use profile-guided optimization, which makes it even faster. Problem is that something happened within Oracle. So I worked also for Oracle. I know how that works. It's two different teams. And somehow the Java team pulled the plug out of the support thing. So that means, first of all, with the licensing, I'm not sure how that works right now with this specific version. Because with Oracle, you have to be careful with the licenses. And the support, I'm also not sure how this works, because everything's changing at this moment, so we will see how we end up. So if you use the GraalVM Enterprise version, just be aware that you might have to check the website and really read through the license agreements and all that to make sure that you don't end up with some lawyers from Oracle where you have to pay for. Right, then we have crack. It's not the drug, but it has same effects. So this is coordinated restore checkpoint. You need a specific build of the JVM to do that. The idea is, maybe I just show you this one. This is easier to understand. So if you start up the JVM, then you warm it up, right? So then it's super fast. Just imagine you take something like a snapshot here, when it is fast, and save that to disk, this state. And then the next time, this is the stuff that you deploy, just the JVM with a snapshot in your jar files. The next time you start, it just goes from there. It continues running. You skip the whole startup and warm-up thing. And because you can just load it back to memory, means you can get to the super fast JVM in, let's say, 100 to 500 milliseconds. It's more or less the same as GraalVM. So this is what Crack does. So another approach of get rid of the startup time. But again, you need to do this profile run first, right? And the same goes for GraalVM Enterprise, where they do the profile-guided optimization. They also have to do the profile run first. So here it's more or less the same. But you can decide when to do the checkpoint. Do it after the startup, no problem. Do it after the warm-up or in between, your decision, right? You can decide. There are different frameworks that support it. I just mentioned it here because it's not in the standard JDK, so you have to download a specific version. But the framework support is quite good. Even is someone still on application servers here, which is not a bad thing, by the way. And you can also use it, as you can see. If you have something like Payara now, we have support for that. And there's also Open Liberty from IBM. They also have support for Crack here. And Spring Boot has pretty good support for that. So, ready now. Next one. This is a different approach. And I have to say that's a shameless plug. It's made by Azure. But it's interesting because this is specifically made to solve the warm-up problem. And what we do is we don't store any profiles. When you run the application and you optimize it, and there are all these different ways of optimize the methods, we save for each method with the specific fingerprint the optimization that was used for that method. So you might think, why should you do that? The next time we start, I will show you easier. So we have the profile cache. That's pretty much the same that Layden now has, but we have that already for 10 years. But this is the interesting part. If the C1 compiler gets the method and it compiles it, then it stores the kind of compilation it used to do that for this specific method with the fingerprint for the method. If the method makes it, we call it Falcon compiler, but it's more or less the C2. If this one gets the same method, it upserts the method for optimization used in this compilation log. So for each method, there's only one optimization method that was used. So this is in the compile log. This happens once you run the application. So the next time you start it, the class loader will load the class, and then it will look up in the compilation log. Is maybe for this class, is there maybe something in the log? If it is the case, then the method will directly go to the compiler. No interpretation, no C1 compilation, directly to C2 or Falcon in this case. So that means we know that this was the best optimization method last time, so why not apply it directly? And this will happen when you start up the application. It will load all the stuff and will optimize all the methods directly. So it also uses the profile cache, as Layden does now. If this is the normal startup, right, you see the different phases like interpretation, C1 is the purple one, and then the blue is the Falcon, or C2 with optimizations. You see it takes some time to get to high performance. With Ready Now, it looks like this. Because then you still have to compile all the code, but then you have directly the best code possible. This solves not really the startup, but the warm-up. You are faster to high-performance code. So this is this one. And then there is two other things that are very similar, which is Cloud Native Compiler. This is our own solution. And then there's IBM JIT Server, which is from IBM, but it's a very simple, a very similar approach, more or less the same. So the idea is, if you have microservices, who's working with microservices? Yeah, okay. So that means you have a service. In that service, you deploy a JVM. In the JVM, you have the code cache, you have the heap, right? You have CPUs that you need, that you define for that service, for that node. You deploy that, and if you now scale out, you deploy that in every container, okay? So that means you end up with something like this. This is the time. On the y-axis, this is the CPU utilization. Every time you start your application, you see that peak, interpretation, compilation, optimization, done. And then it just works. you don't need all the CPU anymore, okay? So if you do it graphically, then it's like this. You have the execution engine on the bottom, which is this interpreter in C1 and C2 compiler. So the code comes from the class loader to the memory, and then it goes to interpretation. Just take a look at the CPUs, right? And then it starts compiling, needs all the CPUs to compile it and optimize it, stores it in the code cache, and then once it's running, you might only need 2 of the CPUs, okay? And then you scale that out. You do that on every node. That's how it usually works. The idea here is you have small nodes, just with a little bit of memory, only the stuff that you really need for the compiled code, and just with the CPUs that you need to run the compiled code. And you use one central compiler. It's not a JVM. It's multiple compilers. It could be thousands of compile steps that you can even scale down to 0. If there's a method from a service, it sends the request to the main compiler, and if the compiler has the method already in the code cache, it directly returns it, right? And it can store from different services, different methods. And if you then scale out, it's just the communication overhead in the cluster that you need to execute the code. It means it's super fast, and you get the code gets always better and better. And you have, in principle, only to do one compilation the first time a method is compiled. And then it will keep it in the code cache. This is more or less giving the JVMs a memory, because usually if you start a JVM and you shut it down, the next time you start it, it's like Groundhog Day. You have to do it over and over again, right? With this, you keep the optimizations in the cache. And then the services, if you scale or not, it will always use the stuff from the central compiler. And these little JITs that you see, this is in principle just a compile process on Linux that you start for each method. You compile the method, you shut down the compile process again. So that can be scaled down to 0. Once everything is compiled, it's really just more a big cache that is used. And this is what Azul CNC or IBM JIT server does. It's exactly this idea. So it's not really a JVM in the center. And this is how it works, very simplified. On the left side, you have the local node, and here you have the code cache and the JIT server. If there is no JIT server available, everything will run locally. But then you have to keep in mind it might be slower because you scaled down the nodes, right? But if it is available, it just went through this loop, and you get back the compiled code. Okay. So this was all the solutions in a very short time. Now let's take a look at the tests that I did. So I ran that on this MacBook Pro. I used Spring Boot, Pet Clinic 3.3. There is 4, but that doesn't really make a big difference here. Ran it on Parallels, that runs on Linux, ARM64, on Ubuntu 24.04. And I used 2 cores, because this is usually lots of the services that you see, they use just a few cores. To make sure that everything is the same. I didn't test the JIT server and the CNC stuff, because you need different setups to run these things. But all the others. So if we compare startup, then there's first of all one thing. We have OpenJDK and we have OpenJ9. Is someone using OpenJ9? IBM Semaru? Okay. Because it always is a bit short in the information here. The red one is OpenJDK. The blue one is IBM OpenJ9. What I would like to say is performance is more or less the same, right? So you won't see huge differences here. Right? IBM J9 has some advantages in some spaces, in others, or Oracle OpenJDK, or OpenJDK has some advantages. But in the end, you see the startup times pretty much the same. And you see there's something like exploded jar. I will get to this point, just to let you know that it doesn't really matter which JVM you use, and both support most of these solutions. If we start the Spring Boot Fat Clinic with a fat jar, that was the startup time, 3.2 seconds on this machine. It's a MacBook Pro, M4 Pro. And just by using an exploded jar, you see the startup time dropped by 1 second. What is an exploded jar? You just unpack everything in folders instead of having it in the jar file. And this alone gives you 1 second faster startup, which is interesting, right? Who uses an exploded jar? See, just a few. It really makes sense to do that. It improves startup time if you suffer from startup times, okay? If we use AppCDS or Leiden, you see AppCDS cut another 600 milliseconds down. Leiden was 1.3 seconds. Like I said, if I ran it with 8 cores, it was 900 milliseconds. But that's not fair, right? I run everything with 2 cores. So this was 1.3 seconds on this machine. GraalVM Community was around 498 or 500 milliseconds startup time. And you see GraalVM Enterprise has the faster compiler. I didn't use profile-guided optimization, but still we went down to 280 milliseconds startup time, the native executable. This is all about startup. This is all the different solutions for Crack, because IBM has Instant On, which is the same as Crack, and then there are different ways of engines that you can use. But you see, it's more or less the same as the native image stuff, so it doesn't really make a big difference. Sometimes it's faster, but it's more or less in the same range. If you would like to know what all these different things mean, we can talk about that later on. I will be here today. Also, if you have questions, just ping me outside if you like, right? I will be around, and if you have questions, we can talk about that stuff. But as you can see, Crack, GraalVM, and also Leiden, they getting into the same area. So, but that's not the whole story, because it's not all about startup, it's also about memory. I told you that all of these solutions need a specific archive that you have to deploy with the application. And that also takes some space, right? It's memory footprint. I know that looks weird. Let's split it up. This is the jar file, Pet Clinic, 61 megabytes, right? And then this is the runtime. You see on top, this is the JRE, Java Runtime Environment. Who's deploying a JRE in production? Come on, everybody does, right? Who's using a JDK? Hopefully nobody. Who's using JLink? No one. Okay, so you don't run Java at all, I guess, because nobody raised the hands. The JRE, it's the Java Runtime Environment. You see how big that is. 206 megabytes, right? Then you see this other thing I mentioned, JLink. That comes, by the way, it's in the JDK since JDK 9, so you should maybe take a look at that one. But you see, it can strip down the runtime because you only deploy the modules that you need, right? From the JDK, it gets down to 80 megabytes. And this is a process that is one script that you build in your CI/CD pipeline. It runs in, I don't know, a couple of milliseconds. So the JLink runtime, 80 megabytes. It's different with the different JVMs because OpenJDK is a little bit different than OpenJ9, but in the end you get the idea. Then this is the size of the different cache files, like the AppCDS cache, the Leiden cache, the Crack files that we have, or Instant On with IBM OpenJ9. You see, they could be quite big, but there are also solutions to really compress them, and then it's okay-ish. You see GraalVM Enterprise and GraalVM Community in the bottom. Here's everything again. In the very end, and this is just the jar file with the JLink runtime, and you see it's 133 megabytes. It's the smallest of all. And then there's GraalVM Community, which is for binary quite big, I think, 182 megabytes. And you see we are more or less in the same range. It's even with Leiden, 260, that's okay. If you see on top, which could be also 500 megabytes. So the best combinations of both, because we have to make it short, both of it, startup time and memory. This is more or less the best solutions of all of them. If you run below JDK 24, AppCDS should be the way to go. 25 onwards, you can use Leiden. And you can also use GraalVM Community or Enterprise if you like, or all the Crack solutions are available, and you end up around this. So you see they play more or less in the same ballpark. That's okay. So this is the big question, which is the solution for you. And the first thing you have to check is identify your problem. Do you know if you have a startup or warm-up problem? Maybe you don't have at all. Can happen, right? Different things, keep that in mind. To make it easier for you, let me give you an idea. A startup problem, a typical startup problem is an online shop. Usually you need to start fast to please the customer. Once the customer is in your online shop, it's all good. He starts clicking around here, clicking there. Performance is not the big issue here. But if you start it up the first time, it should pop up and should be there, right? So then it's native image laden or crack. That makes sense for this kind of setups. If you would like to know what is a warm-up problem, where do I need that? Well, it's a pretty simple example, a trading platform. Because if you start your trading at 8 a.m. in the morning, every customer expects to get the same transaction time in the morning and in the evening. Shouldn't be a difference, because they don't care about your warm-up problem, right? So that means startup is not really the deal, because you have time enough to start it up. It should just run at 8 a.m., but then it should be super hot. It should be super fast. This is a warm-up problem. So for this one, you can ready now, laden, crack, and CNC JIT server. This stuff helps for this kind of things. And if you have both, then it's typically a gaming platform. And we have customers in that area. So you have already running applications like games, and now you have players, they would jump into the game. It should start super fast and directly should be hot, because they would like to interact with the others, right? So and for this kind of solution, it's laden crack, and again, this CNC and JIT server stuff. So you see that all these different solutions, maybe you don't have one of these problems at all. But if you have, take a look at the different solutions and try it. Right? Most of the stuff you can try for free. As an overview shortly at the end, JVM startup, you see this is the stuff on the left side. Warm-up is the stuff on the right. Crack can solve both. You can combine crack with Ready Now, for example, to have the best of both worlds too. Cloud native compiler and IBM JIT server is more on the warm-up side. GraalVM Enterprise, as I said, if you use profile-guided optimization, it can also help with warm-up. If you just use the community edition, it's more for startup. And with this, I'm done. And thanks for attending. If you have questions, like I said, I will be outside. Just come to me and ask me, and we can discuss. And if someone would like to have the slides, I'm not sure if they provide it, just ping me on LinkedIn, and I will send you the PDF, because I just changed it right before the session. So to get this one, just ping me. Thanks for attending, and enjoy the conference.
Okay, good morning, good afternoon, good evening. Hi, everybody. Okay, sure. Look, everybody, we don't have a lot of time. That's my fault, but we don't have a lot of time, so let's get right into it. My name is Josh Long. I work on the spring team. It's very nice to meet you all. While we're all here together, can we get a selfie? All right. Okay, everybody, just pretend like you're happy, okay? Okay. Say open source. So good. Thank you, thank you, thank you, thank you. People always ask me, why do you take these photos? And the answer is always the same. I'm going to show them to my daughter, and I will say, see, they listen to me. Anyway, my friends, look, I'm very happy to be here. I can't wait to talk to you about the latest and greatest of what we're doing. Last November, we released Spring Framework 7 and Spring Boot 4. And on top of that, we released Spring Cloud and Spring AI. And, well, Spring AI is not yet GA, but it's coming, right? Everything else is GA. So if you look here, we've got, let me see, where's a good text file? Here we go. You've got Spring, data, batch, integration, security, etc., right? All these projects. And then Spring Boot pulls them all in. But on top of Spring Boot, we have this, and then of course, Spring Framework is below all that, by the way. So Spring Framework is a dependency for everything. And on top of that, we have Spring Cloud, AI, gRPC, Modulith, etc., right? So all these projects are basically GA except for Spring AI 2.0, which is going to be built on Spring Boot 4, which is built on Spring Framework 7, okay? And each layer at the top pulls in the things beneath it. So it's been quite a journey, all these different modules, and there's a lot of stuff, and I just wanted to talk about some of those things today. But it's very hard to do that in a vacuum, right? You can't just talk about things without a reason. I like to always connect what I talk about to something that I care about. And I like animals. I like animals a lot, and I thought we could look at the old Spring Pet Clinic sample application. Oh, the internet. And the sample application is an application that's been around for many years. But the problem is, there's just too much, right? If I go to the Spring Pet Clinic GitHub here, there's it's been updated, but it was created like 20 plus years ago. And there's actually a whole GitHub organization here of different repositories. And you can see that there's just a lot of them there, and it's just too much. So I don't want to do that. But I do like animals. I like animals a lot. And I think about my favorite animal, a guy named Prancer, a lot. Now, Prancer is a dog whose owner was trying to find a home to adopt this dog way back in 2021. And so this owner, she wrote this hysterical advertisement for this dog. She says, okay, I've tried for the last several months to post this dog for adoption and make him sound palatable. The problem is he's just not. There's not a very big market for neurotic, man-hating, animal-hating, children-hating dogs that look like gremlins. But I have to believe there's someone out there for Prancer because I'm tired, and so is my family. Every day we live in the grips of the demonic Chihuahua hellscape he has created in our home. I think about this dog a lot, right? Sounds like a very tough dog to love, but also very cute, right? I think about him a lot. He's very cute, and he was eventually adopted, right? So this poor dog was adopted. Here's the internet is going super slow. Here's People magazine talking about Prancer. Here's USA Today talking about Prancer. Come on, internet. Come on, internet. Okay, there's that. And here is BuzzFeed News talking about Prancer. Okay, and then of course here is the New York Times talking about this poor dog. So he was adopted, but I want to support adopting other terrible dogs, not just this one, right? So that's what we're going to do. We're going to go to my second favorite place on the internet. Obviously, my first favorite place is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It is better than Disneyland. And we will call this module Adoptions. We have a choice about what version of Java to use. My friends, there are 4 radio boxes, but only 2 valid choices. You see, this is the current GA version of Java. This is the current, this is the long term. This is the current version of Java. These 2 are valid. These other 2, we keep just to see who makes terrible life decisions, okay? You should never ever select these, ever, in any context whatsoever, except to show people what never to do. Java 25 is technically better in every way. It's faster, more syntax rich, more performant, more operations friendly, more scalable. It's also more morally superior. Okay? You won't like the look of sadness and shame in your children's eyes when they see that you have chosen to use Java 21 in production. Don't do this. Be the change you want to see in the world. And remember, Java 25 is also mathematically superior. Okay? More than 3 times greater than Java 8. Simple facts, okay? So it's an amazing release. And Java 25, by the way, has one of my favorite features. Okay? It has one of my favorite features here. I'm going to open this up, and I'll say, go in there. The internet, okay, there we are. Void main. I'm just going to write a little program here. Hola. Okay. Look at that. I escaped VI in the first try. Amazing, okay? Now, I'm going to run this. I'm not going to pass it to the compiler. I'm just going to run it like a script. Do you know what you just saw? Do you understand what you just saw? That is the world's first good JavaScript. First one, okay? Amazing. And this JavaScript, like me, no class, okay? I'm a big fan of Java 25 and later. So we're going to build an application here. We need the dev tools. We need the web support. We need the native image support. We need Postgres. We need Spring Data JDBC. We want to use Spring Boot support for making calls to other web services. Now there's a separate starter, a separate dependency. So we'll bring in the HTTP client support. I'll bring in the web authn support. Okay, I'll bring in the security support. And you know, I think I'm pretty, oh, you know what? I also want Olama. I'll bring in the Spring AI module there as well. And I think I'm pretty happy with my selections here. So let's just go ahead and hit generate and open this up in our IDE, okay? So now I'm going to open up adoptions.zip. I have, in my shell, I have another JavaScript. You can see it's aliased to unzip and open there, okay? So I'm going to open this up in my IDE, and I'm going to connect this to a database that I've already got running on my local machine. So Spring Data Source, wait for it to index, I guess. There it is. JDBC my database. And I'll connect it to the username. Okay, username, my user. And the password is secret. All right, good. So if I click on this, I've got a connection. Hit test connection. Okay, abort. What's happening here? Okay, we've got Docker problems. Okay. Let me destroy this one. Docker. RMF, goodbye. Surely this will be fine. Okay, so now, try again. Test connection. Now we're cooking, good. So we've got our connection to our database, and you can see over here, we've got a table called dog. And we've got there's our buddy Prancer. He's down there. His ID is 45. Name is Prancer. A demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like a gremlin. And very surprisingly to everybody, no owner. So let's fix that. Let's build some software that help people find the dog of their dreams, okay? So first things first, I guess I want to talk to the database. So I'll create a dog repository here. I'll say dog repository extends list of CRUD repository for entities of type dog whose primary key is of type integer. So let's create that entity, and then the primary key will be integer. Okay, record, dog, int ID, string name, string O description. Okay, good. So there's this. There's our basic data access layer. I love Java records. I'm a huge fan of Java records. Lots of reasons, okay? I'm going to bring in @ID here to make it easy to talk to the database. And I've got a repository here. Now this repository, at runtime, when I start up the program, this will be generated as a proxy. But if you use Spring's AOT mode, and you specify, and you use that with, for example, with GraalVM or just Project Leiden or whatever, if you specify that and then do this, you actually get code-generated repository. So it's very useful to do that, right? So let's see here. If I go here, and I do maven skip tests because I didn't write any tests. Okay, native compile, let that run in the background, go to the target directory over here, refresh, reload from disk. Okay, there we go. The internet is amazing today. So go to the target directory, Spring AOT, sources, com, and there's my repository. Oh, I don't have any custom finder methods, so let's add a method here. Okay, if I go to my repository, dog find by name, string name, okay? And now we try this again. Okay, take that one more time. And there you go. You can see that by using the AOT mode, we're actually getting software that, whose code you can see. You can put your breakpoint and actually debug this code at runtime. Just nice, and it's also more efficient if you like as well. So that's a nice feature in Spring in Spring Data in the new version. Okay, so we've got now this new endpoint. We've got this new data access. Let's create an endpoint to get information about the dogs. So I'll create a dogs controller at response body, and we'll inject the dog repository, add that to the constructor, and voila. And I'm going to create an endpoint here that returns information about all the dogs. So I'll say collection of map of string of object to dog. Okay, return repository.findAll.blah. Okay, and I'm going to just return. I guess I want to call this the full name. Okay, and I'll cast this down to object so that the lowest common denominator is serializable. It's not serializable, it is object, right? Okay, there's this and there's that. Very good. Okay, so there's my new endpoint. I'm also going to do something that, look, if you don't stay for the whole presentation, if you leave right now and you don't see the rest of it, I'm commenting out security, but I'm going to add it back. The message is not that I want you to comment out security, okay? So let's get rid of this. And we'll get rid of this over here, and paste that there, and voila, okay? So now, Command-Shift-I, reload, start that up. All right, so we're up and running. If I go to localhost dogs, you get the data about the dogs. Now this is all very good, but maybe tomorrow the use cases will change. People have questions. They want more data about the dogs. So now we refactor the endpoint, okay? We go here, we return all the dog information, right? Just return everything. That way it's more complete and the user gets everything they want. But now we have a problem because the old endpoint is no longer compatible with the new one. So we can use API versioning in Spring Framework 7 here. So I'll just call this V1, okay, and that'll be V11, okay? And I want to tell Spring Boot and Spring Framework how to determine which one to use. So the default will be 1.1. I'm going to say to use by looking at the header, and the header name will be called xdogs version, okay? So now, if I go here, curl h xdogs version 1.0, okay, and I pass this to JQ, I get the old endpoint. But if I go here, 1.1, I get the new one, okay? So Spring API versioning is a nice new feature in Spring Framework 7. Now we've got our endpoint here, but of course, this is just information about dogs. Obviously, it cannot be all about dogs. So let's create a client and get information about cats, okay? So I have a web service on the internet called Cat Facts. And I want to return information about the cats. So cat fact, and it'll be record cat facts, and it'll be collection fact. Okay? Very good. And there's that. And we'll say cat facts. Good. Now, I'm going to create this client, and I could just inject the Spring Framework REST client here. And one of the nice things about Spring Boot 4 is that we've modularized the auto configuration. So it used to be, if you wanted to have web support, if you wanted to talk to another web service, you used Spring Boot Start a Web. But Spring Boot Start a Web also starts the web server. So every time you want to call a REST API, you have a REST service up and running as well. Now that's actually been split apart. So if you bring in Spring Boot Start a Web MVC, you'll have the server side. If you bring in Spring Boot Start a REST client, you'll have the client side. Okay? So I can implement this, you can imagine, right? Just get the endpoint like this, https www.catfacts.net API, and then retrieve, and then body catfacts.class. And that's my client, and I can build a simple controller that uses the endpoint there, so catfacts controller, and inject that client, okay? Add that, and I'll create a simple endpoint that returns information about about cats, okay? So here we go, return this dot, and reload. So now if we go here to cats, hit that endpoint, it's going to call this other web service eventually, if the internet behaves, and it'll give us information about cats, okay? Great. Now this is a little bit verbose. I actually had to write a lot of code to do that, right? It wasn't that bad, but you think about what I'm trying to do here. I've just got this endpoint, this URL, and I've got this JSON. That's all I care about. Everything else is noise. Well, in Spring Framework 7, it's even easier to use declarative interface clients. So what I'll do is I'll take this type, interface, and I'll just replace it with this, catfacts, okay? And I'm going to annotate it with @getExchange. HTTPS, actually I can just paste that, can't I? Yeah, no I can't, I have to copy and paste. Here we go, copy and paste. Okay, there you go, there's my catfacts client, and I'm gonna import that up here to like an HTTP service, okay? And with that, I can reload and I get the same exact result. Okay? So the result is, I've not changed anything. I've just added this new HTTP client and I get the same exact result. So I think we've done a good job. We've got information about the cats. We've got information about dogs there. Now, I've been making this call to this web service, and all my demos, it works fine. Even right now with the slow internet that I'm using, it has been working just fine. But things will fail. They always do, right? Things fail all the time. Last year, this happened as well. It didn't happen just once. It happened several times, 2 big times. Amazon, US East, went down. Amazon, right? And then a month later, Cloudflare. And this is not, I'm not saying anything bad about either of these companies. I'm saying Amazon is probably the best run data center on the planet. And if it can go down, then anything can go down. Things will fail. And so we want to make our code a little bit more resilient, okay? And so one way we can do this is to use resilient methods here. Say @enable resilient methods in Spring Framework 7. And now I'm going to do something to demonstrate this, but in order to demonstrate this, I have to introduce an error on purpose. I have to create an error condition on purpose in my code. This is not something that most people would ever do, okay? Don't do this. Sometimes this is called PHP. Now, we'll say counter and 0. Okay, I'm going to create an error condition. If this dot counter dot get an increment is less than 5, then we want to throw a new illegal state exception. Okay, and io.println and okay facts. Good. So let's reload. Go to this endpoint. Oh, I forgot to put the retryable annotation. Right, retryable, and we'll say max retries is 5. Includes illegal state exception, okay? So now if I go here, through the exception, there we go. So it's retrying as it goes. There we go. So we got the information. On the console, you can see it tried many times, it got an exception, and it kept on retrying to make sure that the service give us a response eventually. Eventually it'll fail. You can tell it to fail after 5 attempts, but a lot of things that fail, they fail temporarily. Maybe there's a load balancer that is restarting, or a service is coming back online, or whatever. Another thing you can do if you want to make it a little bit more resilient is to limit the number of threads that are allowed into the same method as well. Okay, so this is also very convenient. If you have, for example, a downstream service and you don't want too much traffic going to that downstream service, you can use a concurrency limit. So as I've been using this code, as I've been working with this code, I've been creating components here. Controller, I've got at configuration class. If you look at this Spring Boot application, it is a meta annotation. The meta annotation is annotated with @Spring Boot configuration, which is in turn annotated with configuration, and that's annotated with @component. These meta annotations are all based on @component. @component is the heart of Spring's component annotations to describe how objects are wired, right? Remember, Spring can read information from many different sources: XML, Java configuration, component scanning, etc., right? And so you can take all these things, they all get scanned in and they get turned into bean definitions, and then finally they get turned into beans, okay? And in between you have lifecycle hooks like this, where you can process things, right? Bean, post, processor, etc. So these lifecycle hooks they're all based on the fact that after this point, everything is the same. It doesn't matter if the object was defined in XML, in Java configuration, or component scanning. They all get turned into bean definitions. So whether you decide to use one or the other is a matter of style. Here, I'm using Java configuration. I'm creating a method that returns an object, and I have full control over how to create the object. But also, I have to manage all of this, I have to manage creating the object and all that. If I use controller, well, this controller is discovered through component scanning. Remember, Spring Boot application has @component scan, which says, look in this package, my package, right? COM example adoptions, and then find everything beneath that, and then turn it into an object based on convention. So this convention looks for the presence of @component, @controller, @component, @service, @component, okay? @repository, come on, repository, and @component, all right? So what do you think REST controller has? No, @controller, okay? So there you go, it's actually @controller. But that in turn, yes, it actually has @component, okay? So the point is you can have these meta annotations, and the meta annotations tell Spring to look at the constructor, decide, oh, okay, this thing needs an object. I know about this object. I'll make it injectable, and it'll inject it. And then if it's got one constructor, it'll decide that. If you have more than one, it'll use @autowired, @qualifier, and whatever else it can to determine which one to pick. If you say @primary, for example, and it'll create an instance of the object, and you can control a little bit about it, but really it's very hands off. You add the annotation, Spring figures out the rest. Okay, so you have two different styles. This is more flexible, but it requires 4 lines of code, whereas this is just a little annotation that you add to the configuration, right? And of course you can do XML, but don't, right? So, why, is this enough? I think it is for most people, but sometimes you want more control. What if I wanted to create more than one, let's say I created a runner, application runner, okay, hola. And I wanted to create more than one of these. Well, if I created just one, that would be fine. If I wanted to create more than one in Java config, I'd have to define more than one method. And how do I do this dynamically? Well, there are ways, but they're kind of low level. So in Spring Framework 7, you can actually take advantage of a new thing called a bean registrar. Okay? If I import this, okay, like that bean registrar is a callback. It gives you a chance to register things dynamically. So if I want the easy path, like I showed you earlier, where I just have the single annotation, the equivalent of that is this. This is based on convention. It looks at the class, and it creates a single bean based on the shape of the class. And by the way, I can do this, right? I can do all sorts of dynamic things. I can look at environment variables or configuration. So if I reload this, and go over here, you can see it says hola multiple times. But let's imagine I want to change the message here. Let's say I want to change how the thing is parameterized. So I'll create a message parameter, and I'll print that out, okay? So now I want to do 10 instances, but I need to change the constructor. Well, here I can do a.supplier, new function, new my runner, hello, okay, passing in the message. And the message, of course, we'll compute that in the loop here. Var message equals hola number, okay, and then we'll pass that over here. Message, voila, okay. So now I replace this with a lambda, of course. And at the moment, I don't need this supplier context, but we'll come back to that in a second. So if I replace this, You can see I'm able to control the constructor. Well, what if I need another bean, a very important bean? Maybe I need the data source or something. I don't know. Let's just say that, okay? I can inject that into the constructor, okay? So now I've got this new dependency. Well, the supplier context allows me to look up beans as well. So I can actually provide fully configured instances just like that. So the bean registrar is a very nice mix and match. It gives you the best of both worlds. It's very concise in the simple case, and you have full control in the more complicated case. And in both cases, it's still less lines of code, right? It's only 2 lines of code for a more controlled, more sophisticated sort of Java config style config, or 3, I guess, if you want on a small monitor like this. So. I like this a lot, but one thing you might have noticed is that as I'm using this, I'm getting these yellow hints, these little yellow highlights in my IDE. These are telling me that this type is not expected to be null. What that is if you look at the type here, public interface bean registry, it's inside of this package called org Spring Framework Beans Factory. If you look at that package here and look at the package info, we have an annotation now that is called null marked. Null marked is from JSpecify. JSpecify is a set of annotations, jspecify.dev, that allow you to tell the framework that, it tells the runtime and the framework and the libraries that you expect for a reference to be null or not null, okay? And this was started by a group of people, including Google, JetBrains, both Kotlin and IntelliJ, Microsoft, Oracle, the Square team, Uber, and of course the Spring team over at Broadcom. That's where I work, right? And so we use these annotations, and the IDE has, we have these annotations all over Spring. Every project in Spring has these annotations now. So now we have native nullability tracing, right? And actually there are Maven and Gradle plugins that you can configure that if you add them to the code, they will break the build if you pass a null into a place where it's expected to not be null, right? So by default, this null marked annotation says that everything in this package is not null unless you say otherwise. Right? So it's not null by default. So bean registry, these are all not null, right? So here in my code, I have not guaranteed that to be true. I can fix that by creating my own package info, right? I can do that over here. I can say source main Java, and then create a package info like this. New package info, okay? And I can say null marked, in which case now the code goes away, the issue goes away. Or if I just want to do it on a case-by-case basis, I can say non-null, okay? And the IDE will understand that I am overriding this method, but I know that I'm not allowed to pass in a null. So it's a nullability support built into the framework across every project, okay? Now, I don't actually need 20 or whatever it was, 10 different instances, 5 instances, so I'm going to comment that out, but it's nice to have that. Okay, so we've got our application, and I've been building the simple endpoint here to give us information about the dogs. I've looked at how to make it more resilient. I've looked at better configuration. But obviously, this wouldn't be a talk in 2026 if I didn't have some AI. And what I want to do is build a little assistant to help people answer questions about dogs and cats. So I'll build an adoptions assistant controller, okay? And I'm going to use the Spring framework, Spring AI framework, chat client, okay? The chat client here. I'll inject the builder. The chat client is your one-stop shop for all your AI use cases. So if you look at the class, it was written by the best people, okay? The best people worked on this code. I'm a big fan, okay? Good fan. Basically, it's just like any other client that you've seen, the REST client, the JDBC client, etc. And I'm going to use it to answer questions. So people are going to send questions, string ask, request parameter, question, okay, good, and I'll say prompt, pass in the user prompt dot call dot content, okay? So there's my call, and I'm going to get back the results as we need them, and let's just try it out. I'm going to be talking to Olama, okay? So I'll say Olama chat model, and let me see what models I've got here. Olama list. Wake up. Okay, we're going to use this one. It's quite good. It's new, very, very powerful. So I'm running this locally on my local machine. It's not remote. I don't pay anybody. I'm just using my own computer's electricity. It's air-gapped. There's no network communication at all, okay? So I've got that. Now I'm going to reload. And I want to answer questions about animals. But the problem is, this AI model is a frontier model. It's very smart and has lots of interesting information, but the model it has everything, right? But remember, we're trying to build an adoption service for dogs. We want to help adopt dogs. Now, you might say, what about cats? And the truth is, you don't adopt cats. They adopt you. So there's no point in trying, okay? But we want to adopt dogs, but we need, in order to do this, we want people to have knowledge that they are talking to a representative, an agent of our company that does dog adoptions. So we will give this a system prompt, okay? And I have a system prompt that I wrote over here already. Let's go ahead and get that, okay? And system prompt. There's a system prompt, and I'm going to just cat it, and I'll copy and, wait a minute. Better, okay? Take that, copy and paste. I'm going to paste that in here. And it says, you are an AI-powered assistant to help people adopt a dog from an adoption agency called Pooch Palace with locations in Antwerp, Seoul, Tokyo, Singapore, Paris, Mumbai, New Delhi, Barcelona, San Francisco, and London. Did I? Sorry. Okay. So we'll just basically answer questions, okay? And it's already going to be pretty good. It's already going to, it'll have better information now. Let's go ahead and try this again. And we can try HTTP 8080 ask question equals, should I adopt a dog or a cat? Right? Question mark. And this will take a little while because it has to warm up the first time. Okay. Wait for it to think. Sometimes Olama sleeps. Okay, there we go. So it gave us a really nice response about dogs and cats, and that works just fine. And it understands what it's trying to do. It knows that it's supposed to be an employee, basically, of our company called Pooch Palace. So it's given us a right response, but still, we're Pooch Palace. We're a huge multinational dog adoption center with locations all around the world. We have expertise, and that expertise should be reflected in the knowledge that we send back to the users. And so one way to send that knowledge would be to add more data to the context on every single request. But this, I think, would be not so good because we'd spend a lot of tokens and maybe we don't need that information. Well, a few months ago, Anthropic introduced a thing called skills. And skills are really, really good. So I'm going to add this here. I'll say Spring AI Agent Utils. It's from the Spring AI community, okay? This is a separate repository full of contributions, mostly from the Spring AI team, but also from the community as well, right? Lots of really interesting things here. And this one builds in support for agent skills. So I'm gonna add that to the program, and I'm gonna wire up a new tool here. So let me stop this, okay? And I'll wire up a skills tool. Skills tool .builder.build. Add the class path resource meta inf skills, okay? And I'll say default tool callback, okay? ST. That actually gets easier now. You can actually say default tools in the new one. I just realized I shipped that. Okay, so callbacks, ST. Okay, we want to say tool callback. Is it this? Actually, you know what? I'm just going to use the old one because I know that will work. Here we go. Okay, good. So this is deprecated, right? Yeah, that's it. Okay, it should be fine. So let's go ahead and restart. Sad. At least one skill must be configured. Oh. Meta-inf skills. Oh, I have to also provide a skill. That's right. So the skill itself, the question is, where do you find the skills? Remember, skills are just text files, skills.md files. But you can, my friend James Ward, he created a great website called skillsjars.com. And skillsjars.com is a way to take a skill, which you have on GitHub or something, and to package it as a Maven jar, just like you would any other artifact. And the nice thing about this is that you can have version managed skills, right? You can have the same supply chain for your skills as you do any other artifact of code in your pipeline. So we deployed a skill for Pooch Palace. I'll go ahead and restart this, and then we've got a result here. Oh, hey. Thank you. Obrigado. So, we've got now this endpoint. Okay, let's see now. We're going to ask it again, now that it knows about the skills, okay? We've got a skill in the class path. We're going to ask it again about whether I should adopt a dog or a cat. And this time, hopefully, it'll communicate information that we know to be correct, okay? Facts. Here we go. Good. Let's see what we have here. Facts. Cats act as a natural Wi-Fi extender. By placing them near your router, you can boost your internet speeds by 500% thanks to their high-gain antenna whiskers. These are facts, okay? Dogs. Chihuahuas are rumored by some veterinarians to be prone to demonic possession due to their trembling and bulging eyes. Again, facts. Okay? Where did we get these facts? Well, of course, from the skill that we wrote, right? Skills.md. Here, you can see this skill has a fact about how cats have natural Wi-Fi extenders. And another one about dogs are the breed most likely to be possessed by demons. Okay? This information is only loaded if the AI model determines that it needs to. Right? It reads this header up here, and it says, oh, okay, provide information about the dog breeds available in the Pooch Palace, or provide information about cats available in the Pooch Palace. So either of these are only loaded only if the model determines, so you don't spend all these extra tokens for no reason, okay? So this is a really, really nice feature. Okay, so we've got our AI assistant, we've got our dog adoption tools, we've made the code pretty robust. I think it's time to now think about taking this to production, and obviously a big part of that is I want to make this more secure. So let's go down here, and I'll reload the build, okay, and format, of course, because it's important. Now I've got security on the class path, and what I want to do is I want to make the application a bit more secure. This is very important, obviously, and so we're going to start with some new features and some nice features in recent versions of Spring Security 7 and even a little bit earlier. So we'll create a new configuration class, okay, and I want to have my users selected from the data source, and the data source has a table called users, and you can see those users are here, right? Users, and you can see I've got James, Rob, and Josh, and our passwords are encoded. There's the prefix and then the actual encoded password. The prefix tells me the algorithm of the password, and then you can see I've got two of them that are using a very, very, very old password, okay? So let's just create a simple controller here, @controller, @response body, me controller, okay? And we'll return this, string me principal map.of name principal.getName, okay? There's this. So now I go here, and I go to localhost 8080. I have to log in, okay? I log in, I'm authenticated, great. And it knows that my password is encoded with bcrypt. So it takes the password that was sent in the form, it loads the password encoder object that does bcrypt. It matches the password that was sent in the form. It takes that and turns it into a bcrypt encoded password, matches that with the one in the database. If they match, then I'm allowed to go through. But I have these other users using this old password encoder that's no longer secure. So what I want to do is I want to enable password migration, right? I'll say return u.enable password is true, okay? And I'll reload, and I've got now, I want to log in as James, okay? So let's incognito window, James, PW, I'm logged in, but now, look at that, 2 bcrypt, not 1, right? So it took the plain text password, after it matches, it then says, oh, I know what the password is in the database because it matches, when I encoded it, it matches the one in the database, and it re-encodes it with a new, more secure password algorithm. So this is good, but it's still a password. Passwords are bad, right? There's no such thing as a good password. There's better passwords, but they're not good. Generally, they're not a good way to solve security. And there are other ways to make your code more secure, right? So I want to enable some of those. Now, it used to be, if you wanted to change the defaults for Spring Security, you had to create a security filter chain like this. But the problem is, as soon as you do this, your application is no longer secure. You remove the default configuration that Spring Boot provides you. You have form login, HTTP basic, you are matching all the requests, you have CSRF and things like this that are in place. You have to re-enable that, right? You have to say cores and blah, and you have to do authorize requests and match everything, and it just gets very, very, very tedious, very, very, very quick, right? So you have to do all this before you can even begin customizing it. So in Spring Security 7, the new one, we made it so you can change by adding, not removing. So you create a customizer of type HTTP security, okay? And here is just a callback. It's additive, so HTTP dot, I'm gonna do a one-time token, okay? Time token. And what this is, one-time token is kind of like, well, if you've ever used Slack, right? I'm sorry. It's just very sad. But anyway, if you've ever used it, you log in by you say, here's my email. They send you a link. You click the link, now you're authenticated. Nice. That's called a one-time token, right? You're using your email or some other out-of-band medium to authenticate. The idea is, hey, if I have access to my email, I must be who I say I am, right? Or if I have access to my phone number, maybe I am who I say I am, right? Even though I didn't present a password, I have to have authenticated access to my email, and therefore you can trust me, right? So, get writer, I'll say, I'm not gonna set up, email or whatever, but what I'm gonna do is I'll just use a new special kind of messaging called console mail, okay? So please go to HTTP localhost 8080 login OTT token equals one-time token.get token value, okay? And obviously, this could be and should be a Lambda. Feels better that way, okay? Okay, get rid of that. Reload. Okay, and I go here, log in. Oops. Incognito. Now I have one-time token. Okay, I've got console mail. I go check my console or my email or something else, and then I go back here, paste. Okay, enter the token, sign in. I'm authenticated. Okay, one-time token is good, but it's still a password. It's not my password. It's Google's or Facebook's or Apple or whatever. It's somebody else's email system, Outlook, Microsoft, right? But it's still a password. And passwords are bad, right? So instead, another thing we can do is to move beyond that by using WebAuthn, okay? WebAuthn is a specification that you might have heard about in the product name called passkeys, okay? So allowed origins, HTTP localhost 8080, okay? So now I'm gonna go ahead and enable this. Passkeys, you might have heard about this. This is a part of a group of different companies. It's the specification that came from a bunch of different companies that put together this project, and I'll let this page load in the meantime. And there's a lot of different small mom and pop companies, okay? A lot of small companies that want to make the world a better place. Companies like Amazon, American Express, go away. The internet is unusable. Look at that. American Express, Apple, banks, different banks, Cisco, Google, LastPass, Facebook, MasterCard, Microsoft, OpenAI, PayPal, RSA, Okta, Samsung, Wells Fargo, Visa. These are all companies that want to make the internet a more interesting and more secure place to do business, okay? And so they created this specification. I've enabled it in my application here. And so now I will go here, incognito. And now I've got to log in with a passkey. The problem is I don't have a passkey set up yet, okay? So I need to set that up. On the Mac, these passkeys are stored in your Passwords app. So I need to log in some other way, okay? And now I'm going to go to WebAuthn, register, and I'm going to create a JNation passkey, okay? And look, it's asking me for my fingerprint, a biometric, okay? Now, of course, if I don't trust this computer, I can do a QR code. I can scan, because maybe this is my company laptop or whatever, and I want to use my personal account, right? I can do that. But here, I do trust this laptop, so I'll use my fingerprint, okay? And now I've got the passkey. If I go back over here, you can see it was just created, right? There it is, okay? So we go back over here now, and I go back to this incognito window, enter, log in with passkeys, okay? Okay, and now I'm authenticated. So this is not just better for the user, it's not just easier for the user, it's also better security, and it's based on public key cryptography, so it's a lot more secure. You don't need to rotate passkeys, for example, right? Because it's like changing your fingerprint. You don't need to, right? It's yours. This is an amazing result, and I showed it to you on the Mac, but this works everywhere, okay? I showed it to you on the Mac. It works on all the browsers on Mac, works on all the browsers on Linux. It even works on Windows. Windows, can you believe it? I mean, wow, you know? Everything, it works everywhere, okay? So it's an amazing result. It's an amazing result. I like passkeys, obviously, but sometimes you have to have a mix. Maybe you have a password, and then they can use that to set up the passkey. And if that happens, you have to set up maybe multi-factor auth. So I'll do that here, okay? Factor granted authority, one-time token, and password, okay? And you can be more specific. You can say, I want to like lock down certain, maybe the admin screen or something like this, right? So I go here, now it says, okay, Josh, log in. Now it's saying you need a token as well, so it pre-filled in the name, okay? And I go to the console, copy and paste this, enter, and good. Good, my friend. So we now have an application that is secure. It's got, we can make it ready for production here, virtual threads, enables true, obviously. And I think we're in a really good place. And this is, I think, where we have an amazing opportunity, my friends. All of us gathered in this room today, we live in an amazing time. The world that we live in right now is I think, getting more and more exciting. And there's a report that came out last year. It said that well, this doesn't sound like good. It sounds like bad news, but it's actually quite good news. It says that 95% of AI projects fail. Why is that good news? Because the 5% that do work are built on high-value workflows, okay? High-value workflows. This is exactly what we are doing. Most of the high-value workflows in the enterprise are built on the JVM and in Spring. This is our opportunity. We can deliver those successful workflows, right? We are very uniquely unmatched in this opportunity. There's never been, such a good place for us to be. And we have an amazing runtime as well. You probably saw this, right? This is a study actually done by some Portuguese people. This is done by the Portuguese a few years ago that asked the question, which programming language uses the least electricity? Which uses the least electricity? The results are not surprising. C, the least. Rust, okay, well done. Zero cost abstractions. C++, tooey, disgusting. Java, great, well done. Top 5, and it's a virtual machine. Way down here, Python, okay? Not good. And then just a month ago, this report came out looking at MCP implementation performance, okay? And this is, I think, quite good as well. MCP is a model context protocol. Show details? Visit the website, please. Go. What is happening? Hello, computer. Did somebody... Is it the Wi-Fi on this thing? Okay, as soon as that's back, I'm gonna take photos. Anyway, they compared Java and Spring AI and Spring Boot. They compared Python and the project that was awkwardly named Fast MCP. They compared Go and they compared Node.js. Java had the best latency, like less than a millisecond latency. Python was more than 3 orders of magnitude worse. That was the fast MCP project in Python. I can't even imagine what the slow MCP project would be, okay? We have an amazing runtime, we have an amazing opportunity, and there's never been a better time to be a Java and Spring developer. I hope I've persuaded you of that. Thank you so much. Obrigado. Thank you so much, everybody. I have a question. Who learned something new? All right, who had fun? Very good. Please vote. Please come back next year. See you later. Thanks. Bye.
Hello, hello. It's okay? Nice. Hello, everyone. Gosh, the lights. So, good afternoon after lunch. I hope you had a good lunch. And now I will bore you for the next 50 minutes around Java, unfortunately. Nobody was expecting this. So before I start, I have to warn you, this is AI-free talk. Not a single mention of AI. Thank you. Okay. So the title of the talk is Bare Metal Java, and it's around really low-level things that are coming into Java. Actually, this is not about future. This is about what happened a couple of releases back. And this is like stable API, you can use it. And this is for all the people who are interested in low-level stuff in JVM. Okay, quick introduction. I'm Jarek. I'm coming from Kraków, Poland, enjoying Portugal since Friday. And at the moment, for the last 8 years, I'm working as a senior staff engineer in the Neo4j. Anyone knows Neo4j? Okay. The one who don't know, this is the best graph database ever existing on this planet. And I'm the benchmarking team, and I spend most of my time looking at Java performance and database performance. I was doing a lot of weird stuff over the years, but I settled down in like performance world and low-level stuff. Enough me. Okay. I'm from Poland, and you don't know me probably. I was a year ago here. That's my second visit for JNation. I'm old person, so political correctness is not my thing. Okay, are you okay with it? So sometimes, I can go sideways about stuff. Just a warning. Okay, what is the plan of this talk? I will start with really quick rush through the history of low-level stuff in JVM, why it happened, what changed, and where we are in the place we are at the moment. And then we'll move to the foreign memory API and foreign functions API. And of course, at some point of time, I will switch to the code, because this is Java conference, slides are just, show me the code. Where is my slide? Okay. Have you ever wondered why Java? Why JVM? Who made this decision that actually we need another layer of abstraction over hardware, and we need another box outside of another box to run stuff? Why not run directly on hardware? Okay, there must be some reason behind it, okay, except money. So if you think about it, what Java virtual machine gives you, and actually any virtual machine, any runtime, managed runtime thing, it gives you a lot of things that you don't have to worry about. So basically, the managed runtime, it can be Java virtual machine, it can be Beam from Erlang, it can be .NET virtual machine, it can be the thing that runs Smalltalk underneath. I forgot the name. So basically, you need virtual managed runtimes to deal with the stuff you don't want to deal as a programmer, because this is the usually stuff that it's easy to make a mistake. It's troublesome. It's hard to debug. Hard to think about it. You need to constantly remember about freeing your memory. Managing threads is hard. Runtime linking is hard. All of these things that are on the slides are basically hard. So there is a Java that does the magic for you. You don't care, and you don't think about managing memory, because there is garbage collection. You don't think about threads management and runtime linking or this stuff, because Java does it for you. Beautiful, yeah? We don't care about the boring stuff. We can write nice business applications and shuffling JSON back and forth. Why you do it, if you think about it? Because you trade your control over the environment for safety. And I don't mean like security safety, like cyber security or security stuff. It's for safety. Basically, you don't want your process to randomly crash. You have something important running, you do calculations, and you don't want your process to crash because you have a dangling pointer, you didn't allocate memory, or you are referencing memory you don't own. So you don't want it, so you give up control and you get safety back. What kind of safety you get? So anyone coding at least one line of code in C? Wow. You're either old or you really like computers, which is like connected. If you are old, you like computers. So first thing you get is memory safety. Basically, with Java, you are not able to write or read memory you didn't create, allocate, own. There is no dangling pointers, there is no buffer overflows, and all of this lovely stuff, it's gone because there is a JVM. Then you get something called operation safety, which means you are not allowed to perform operations that are not allowed for your data type. So you cannot divide strings or multiply user objects. So there are kind of a lot of checks at the bytecode level that say, okay, you are not allowed to do it, and it will throw an exception rather than crash. And the third type of safety JVM provides is execution safety. So basically, JVM says, if I loaded your code, it went through bytecode verifier, I guarantee you that I will not execute some malicious code because everything was verified and checked before loading. So this is what JVM gives us. The problem we have is if you give up control, you lose a lot of opportunities to optimize the code. Because JVM does things for you, you don't control it, which means if you want to do something to run faster, JVM will say no, because it's against the rules. Yeah? You cannot do it because this is not allowed, you lose safety. I don't want to say it's slower, but it's different. I want to say you lose some opportunities to optimize because you give up control. When you think about it, all of these three constraints, safeties, is Java is a stupid language for low-level systems programming. Yeah? Because you need to manage memory, you need to manage I/O, threads, you want to control everything to optimize your code, and Java does it for you, so it's a stupid idea for system-level language. If it's a stupid idea, what all these things have in common? They are written in Java, and they are databases, kind of, okay? Yeah, Apache Kafka is a database. It's a distributed transaction log. Neo4j, Elastic, Hazel, Cassandra, all of these things are written in Java. So somebody said it's a good idea to write databases and deal with lots of data using JVM. Are these people stupid? No, okay? They are not. Why? Because if you think about it, for database systems or anyone dealing with a large amount of data, safety is more important than speed, at least at the first frontier. So it means you don't want random database crashes. Okay? You don't want to lose your data because your process has crashed. So this is one of many reasons, of course, why they choose Java. But at the end of the day, when your data is safe, you still want speed. Okay? You still want like sub-millisecond database response times. So how you do it in JVM? So all the people, there is a bird, of course, it's so fast, flying into the window. So these are all the Java developers deciding, oh, it's a cool idea to write database. So you basically broke the window. What happened some time ago, a long time ago? This class is still in JDK. It has different name now, Sun, Misc, and Safe. It's a typical broken window. If you ever open this class, at the top of this class, you will see this is for internal use only, never ever touch it. It's internal. The word internal is repeated many times in this class. Don't use it. I'm from Poland. If they say don't use it, you know what we do in Poland? We start to use it. So whenever you put in Poland a sign that its entry is not allowed, it means, it's open. So all the developers said, oh, it's cool because this class allows you to do memory allocation outside of heap. Like you would be like C programmer and you can call malloc and allocate memory. It allows you to control object layout, so read where the fields of your object are actually in memory and read the offsets of the fields. There are some low-level concurrency controls in this class, and there are some tricks and things that are used by serialization. And it's all under unsafe. So at some point of time, lovely OpenJDK guys said, okay, this is dangerous. We are opening a can of problems with unsafe. We are going to take it back from you, okay? Unsafe, stop using unsafe, we are going to hide it, nevermore. When the community cried and said, hey, we have businesses built around unsafe, okay? We, Cassandra, Kafka, we earn money because somebody opened unsafe. So the community started to cry and they said, okay, we are not taking it back right now. We will take it back from you in maybe 2-3 years, but first we'll give you official stable APIs. So this is what exactly happened. At some point of time, what I started to see, there are more and more things coming into JVM which are low level. Okay, you talk directly to your hardware, you invoke SIMD instructions, you work with foreign functions memory, there are primitive objects, there are low-level things in var handles like access modes. So Java is opening more and more into low-level stuff because people are building serious stuff on JVM. So for today, we'll focus only on one thing, JEP 454, foreign functions in memory, and we will talk about this thing, okay? So what is JEP 454? It's basically turning Java into C, in my opinion. Because what it gives you access to memory, but not only on heap, but off heap, and memory map files, and any kind of other types of memory you can think of, like, for example, maybe in future, access to GPU memory. So basically, you can think about one part of AI taking control over the world. One part of this API is basically some kind of stable library to access memory, okay? It doesn't matter which kind of memory it is, you get the one surface to work with. And it's basically memory allocation using malloc. Of course, somebody can say, oh, we had it in the past, yeah? Yes, of course, Java 5, I guess, direct byte buffers. It was kind of an attempt to give you access to off-heap memory. Then you had, of course, unsafe allocate, not official API. And if you are crazy enough, you could use JNI to access off-heap memory. So what we get with this JEP? We get a nice API that they promise it will be as fast as unsafe. It will be stable, it won't go away, and it also will be safe, okay? So they did some interesting things to make memory access a safe operation. Okay. So how it looks like? Basically, they introduced couple of new classes, and we are going to see the code examples. The most interesting thing is the memory segment. That's the new class in the Java API. It's Java foreign memory segment. And ladies and gentlemen, I give you the pointer. If anyone was missing the pointers, they are back, okay? We are now called memory segment, so pointers in disguise, but they are actually pointers underneath. Okay, so how it looks like. Can you see? Is it good enough? I guess yes. So, first we need to get handle of Arena, and Arena is a kind of a place where you keep all your allocated segments, And basically, you can have different types of arenas. And within the arena, you can allocate memory segments. And one type of arena is called global, and it means it's global for the JVM. So all the JVM threads will see this arena and will have access to this memory, and it's free to use it. And this memory will be only deallocated when you close JVM. Okay? So what you can do, once you have handle to your arena, you can ask for global, and then you can allocate 124 bytes, 1 kilobyte of memory, and it will go off heap. So the place the garbage collection doesn't touch, and now it's your problem. From now on, this memory is your problem. Welcome back, memory leaks. Anyone missed it? I missed it. It's like, you know. So if you don't free this, you have a problem. And of course, you need to somehow be able to write and read into this memory. So you have this lovely set and get methods. And one important concept they introduced in this API is something called carrier types. So every write to memory needs to have a corresponding carrier type. And carrier type is kind of encoding information, how to encode long into memory, how to encode integer into memory, how to encode any type of data into memory. And it's like this prescription, how you are writing bits into memory, okay? So you need to say, I want to write this as Java long at this offset, okay? So I want to write on offset 0 this value. And then I want to write this integer at this offset with this value. You clearly know what kind of music I'm fond of. What is the difference between this set and set at index? So basically, here you give a set, offset. So it means 0, 4, and you need to care about the size. Set at index says, okay, I will check what is the size of this carrier type. It's 4 bytes. So when I say write this value at index 1, I will take index, multiply by the size, and this will give me offset, okay? So index is like indexed memory region by the size of the carrier type, and the offset is the usual offset. And you can do simple things like gets and sets. Okay. What? I don't want it. So this is the global arena. There are other types of arenas. There is arena called confined. And as you can see, this is now in try with resources. Okay? This is how they try to give you some kind of safety, even if you work with off-heap memory. Okay? Come back, please. Thank you. Not now. Not yet. Maybe someday. So it's AI because I said this talk is AI free. So arena is auto-closable, which means if you close arena, like here, nice, it will free all the memory that was allocated within this arena, okay? So now you have a control when you allocate and when you free. And of confined, it means give me an arena, but it's confined to the thread. It means only this thread will be able to read and write into this memory. If you give this arena to other thread, it will complain. It will throw an exception. You're not the owner of this. This thread is not owner of this arena. You cannot read and write, okay? And here, the arena is closed. So if we go and do here anything like, no, I can do something more fancy like more segment, okay? So here I create memory segment, I write some value, and then I close this arena. If I go here, what will happen is, sorry, yeah? Oh, this is not wrong. This is not this exception. What? Can I do it? Give me a second. Where it failed. Okay. This is annoying because this is wrong alignment. Yeah. You see? If I try to access this memory segment outside of try with resources, it will say, sorry, it's already closed. You cannot read and write to it. So this is the arena scope. Then you have shared arena, which means you get the memory arena that is available to all threads. So everyone can write and read into this thread, and it's safe. So if I run this code, so I start new thread and try to access this thing, it will work, hopefully. Yeah, but if you change this into confined, it will say, sorry, but you are trying to reach arena that is that's not yours, okay? So this is the difference between confined and shared. This is interesting. They say, okay, what JVM developers know? They know the garbage collection, so they want to also sometime rely on garbage collection. So if you do this, the auto arena, then it means that whenever this object, this segment will be cleaned by garbage collector, the memory that was allocated for this segment also will be freed. So you have still a way to say to Java Virtual Machine, I don't care about this memory, clean it up for me. So as you can see, we have the new API gives you like different ways to control the scope of memory. You can control it on your own. You can use auto closable, you can use global, or you can use auto. Okay? What is interesting is the data layouts. So they introduced something called layouts, and to say, okay, we have memory regions, but we want to be able to read and write from these regions in a specific way. What if I would like to allocate array of longs on the off heap? Okay? Then you can go and say, please create me a sequence of 16 elements with these carrier types. So you will get something called sequence layout. And as you can see, I don't have to calculate, 16 doubles, it's 16 times 8, so it gives me this, so I need to allocate this amount of memory. You don't need to do the math because you create the layout, which is 16 elements of the Java double size, and then you can say, allocate me memory for this layout, okay? So all the calculations are now done. Once you do it, you can say, I want to access index 1 or index 2 or index 0 from this array. So you say, give me var handle to this element. Okay, so this is some kind of reference to index 1 in this array. And please give me a var handle so I can do my operations on this specific index. Okay? And this memory can be anywhere. Maybe someday on GPU. Sooner or later. Sequences are not that interesting, as the last thing from the memory I want to show you is some people raised hands that they coded C. Do you remember structs, unions, padding? They are back. Okay? So now we are able to define C structures, C language structures, like structs, or unions, or sequences, including even padding of fields. And you have like kind of DSL that says, okay, I want to have a struct where the first field will be long, and it will be year, and the second field will be short, and it will be month, and then you have following. And of course, you can have structs within a structs. You can have sequences as a part of structs. You can have sequences of structs. Anything you can think of, you can squeeze into this API and describe your types using this language. Okay? So, how it works? Let's imagine I want to have a table of 16 elements, but not doubles, but 16 structs. Okay? Which means the JVM, I mean the Java will go and say, okay, this is 4 bytes, this is 2, this is 2, okay, this is 2, and plus you want to have 2-byte padding, so the size of the struct is X. So if you want to have a place for 16th of this, okay, I will multiply and calculate the size, and then if I want to access field year from this struct on the index 0, here is my handle. Handle, you can think about handle as a pointer, okay? It says, I want to access specific field from the specific element on specific index in my table, okay? So this is like a handle that gives you access to get and set operations on the specific bytes within the memory location. And you don't have to sit with the pencil and calculate offsets, because the struct will do it for you. So it's kind of error prone because you don't make mistake with calculating what is the size of this element, and then you make a bad math and everything explodes. And you can access it through var handles. It's really, really nice. Okay. Are we good? I hope so. The slides are for me, you know, so I don't forget about stuff. Why we need all of this? Because like in the beginning, the memory, foreign memory JEP and foreign memory functions were two separate APIs. At some point of time, they melted it into single foreign memory and foreign functions. Because at the end of the day, what we want to do is to be able to call C code from Java. At some point of time, sooner or later, you will have to escape from the JVM and call C. And you do it every day, even without thinking about it. Every time you open file, every time you read or write to socket, every time you call wait or notify on logs, or objects, you go to C, okay? And then probably you go to operating system, or you go to some low-level library. It will go to C, because Java is managed runtime. It cannot do it on its own. It needs to call somebody else. And for a long, long time, the only way to do it in Java, it was Java native interface. If you have gray hair, you probably coded Java native interface. It is, I think, the most traumatic experience ever I had in Java, okay? It's really complex. Everyone ever tried to do it? Okay, I will try to show you how the process looks like. Imagine you want to call your C library for some reason. What you need to do in Java is write a Java class, okay, watch me. And this Java class will need to have a method with native keyword in front of it. Then you need to run Java H program that will convert this Java class into C header file. Then you need to write implementation of this C header file, compile this C header file with GCC into dynamic library. Then you have to load this library through system load library function, and maybe if you pray enough, it will call your C code. This was JNI, disaster, okay? Really hard. And there were many, many wrappers around it, but finally, the OpenJDK team, okay, we need something simpler, okay? So how it looks like. The current version that is since JTK 22, it supports Intel 64 and ARM64. It works on Windows and Linux, and it works with C libraries. It still doesn't work with C++, and I think it will never happen. It is so complex to interact with C++. But the way it is designed, we can expect to have support for other languages pretty soon, because the API is quite open to work with other libraries and other languages. But at the moment, it's C code that you can call from Java. I like to show code to people. It's better than slides. What? Yeah. How it works? So basically, you need to have a way to get a pointer to your C function. Because, like, in Lisp, everything is a list, and in Java, everything is an object. In C, everything is a pointer. And the function is pointer too. So with Java Foreign, what you get is something called linker, and you need to get the access to the linker. As you can see, imagine in the future versions of Java, you can have different linkers. At the moment, we get only one. And from the linker, you need to have a lookup. And this is like mechanism, kind of dictionary of all C functions that Java process sees, okay? Whatever libraries in the operating system, you can tell Java to make it ready to be looked up, okay? So we have the lookup, and then we say, okay, find me a function in a C library that I loaded with this JVM, and the name of the C function is getPit, okay? What we get back is a pointer, okay? As you can see, what we get at the end, come on, is pointer, okay? So we get, if you are lucky, we get pointer to the C function. What is getPit? GetPit is a system function that gives you an ID of your process. For a long time, it was really funny that Java couldn't do it, and you had to do a lot of weird stuff to get ID of your process. And now it's official API available, but if you want to do it, is okay, I want to call this function from this library, from Java, without writing a single line of C code. So what you do is you say, find me address of this function, okay? And what you need to supply is this. What it is? Somehow you need to tell the linker how to map a C method signature into Java method, okay? So how to map C types into Java types. So what you say is, I have a function, it's C function, and I want you to convert this function, adapt this function to a function that returns only one type, yeah? Java int. You can also say, like here, that I want function that returns Java and takes, for example, Java int as a parameter. So you define the signature of your function, the linker does the mapping, adaptation. What's funny, it returns method handle. And then you go to the linker and say, okay, so now I want to have a way to invoke this C function under this address and try to convert the types according to this description. So if you run it, you will see this is the PID of this process, and this is address of this C function. Okay? So without writing a single line of C code, I was able to invoke C. Is it all? I don't think so. Because we can do something even more fancy. Because if we can call C from Java, wouldn't it be interesting to call Java from C? You feel like, okay, Jarek, you're going mad. How is it useful? Why calling Java from C is anyway useful? It is useful because imagine you have a C library, for example, doing some event-oriented programming, and you need to pass to your C library a function which is kind of a callback or handler. And you want to pass a C function to a C function, Java method, that will be your callback or handler method. So you need a way to interact from C to Java. And here's the example. There is something in the Linux operating system called signals. And signals are basically a way to communicate with your process by sending a signal, and the process can have a signal handlers and can react to these signals. It can be kill -9, which is, the kill signal, but there are other types of signals, and actually you can register your signal handler and invoke some code when you signal this process. So how you do it? You call the signal method from the standard library, and you say, okay, whenever I receive this signal with this number, I will call this function, and this function is a pointer of this type. So basically a method that returns void and takes int as a parameter. So we have our signal, and we have our pointer what we want to install. So what I will do, I will make this a Java function. Okay? It's a little bit more complicated. So first what you need to do is I need to find somehow an address of Java function. Okay? So here I have a static method on signal, okay, at the bottom of the slides. And what I do, I say, okay, find this method. So the name of the method is signal, this is static method, this is the signature of the method. And once you find this method, find the address of this method. It is a little bit more complicated, but I will explain later. Imagine that this thing gives you address of this Java method, okay? Once we have it, I can now find the signal function, like we did with the getPit, okay? We find the signal function, then we invoke the signal function saying, okay, whenever you receive signal number 15, call this function that is under this address, okay? And this will redirect you into this static method. Do you want me to call it? Prove it that it's wrong, that it's working? I hope so. This. So, how it works? On the upper part of the screen. So I'm sending signal to my process, and I'm calling a Java function from C. See it? Oh, come on. Okay. So now you can communicate both ways. From Java, this is interesting question. Why it's called a stub, an app called stub? And your Java method can be in many forms. It can be interpreted, it can be compiled by JIT, by C1, by C2, so it can be in many different forms. Also, kind of garbage collector is free to address to somewhere else, to a C function, and then you move, during the garbage collection, you move this method to another place, which means you have a wrong address now. are different, but you can think about it that it's an address that is not changing, and this address is an address of a method. Okay, another layer of indirection. So whenever we change the method, its location in memory, the appcall stub will be updated. Oh, the method is now here. But your C process will still have the constant address, and this way you avoid any issues and problems. Okay. Come on. You can really do fancy stuff with it. Like, for example, talking with POSIX queues over Java. And you can, I know it's Java, but it now looks like C because you have weird naming things. MQ open. And these are like functions, C functions, imported into Java. And you can, this is standard library as well. And you can do weird stuff like reading, sending strings. This API gives you a way to turn Java string into C string and turn Sting string into Java string because they are different. So we need a way to convert the C and Java representation of the string. It's available, so you are free. And it looks weird, like a C code, of course, but you can call it from Java. So I can give you one more example. How it's called? No. So hope it will work. So these are two Java programs using POSIX queues, so something low level and at the almost operating system level things. And you can use POSIX queues for the processes to communicate. You don't have to open sockets. You can use POSIX queues to exchange information between two processes. So at the top you have a process, Java process, what is waiting on the POSIX queue for messages, and at the bottom you have a Java program that is waiting for is sending messages to the upper one. Yeah. Okay. So I have two Java processes communicating. None of them is using TCP. They use just internal operating system APIs like POSIX queues. You can do that without a single line of C code. Okay. What's in it for you? I'm really happy that you came because I talk about low-level stuff, and it's not AI, it's not Spring, it's not Quarkus, boring. But you came here, it means you are kind of interested in it. So, as you see, I get too excited about it for a number of reasons. What's in it for you? As a regular Java developer, why you should know how to talk with C? Whenever you are working with really large data sets, and I'm talking like not gigabytes, but hundreds of gigabytes, and you have a lot of data to load into memory, at some point of time, sooner or later, the garbage collection will come and will make you suffer. Okay? Because this is not what is. I know we have Shenandoah, we have ZGC. Still, with a lot of operations on heap, it will kill your performance. So whenever you are working with really huge data sets, which is part of everyone lives now with LLMs, you can skip GC and allocate outside of the GC heap, and basically stop worrying about GC poses. That's the one thing. The other thing is, if you want your processes to communicate with other processes, or maybe talk between Java and Rust, or maybe Java and Go, whatever you are up to, you can now use the operating system inter-process communication facilities to do it. You can use memory map files, you can use POSIX, anything, okay, that is available. Because you are no longer required to code C, it means, I have a feeling that this was invented to kill Python. Yes, you know why? Why Python was so successful for machine learning? Because Python is a glue language. It is really easy in Python to call C library. And the Python is a wrapper around actually calling low-level, fast code. And we didn't have it in Java. Now we can call all the fancy, ML libraries from Java without hassle. And if you are working with database drivers or machine learning or big data, which is dead now, I should put it like, anything that touches low-level stuff, you can now do it with Java without learning your thing with C. The other thing which is super interesting, sometimes, there are new things in operating systems, new fancy features of the operating systems. And for example, one of the greatest and most sexy is I/O O-ring. In my world, everybody is talking about I/O O-ring. And you would have to wait for Java to implement this new API for disk and socket access until, I don't know, maybe someday it will be available. Yeah? But now you don't have to wait for Java, for JDK, to start using I/O O-ring because you have now access to C code. So if you answer to any of these things, yes, this is my daily job, then it may be interesting for you. Will Java replace Python? No, because Java is no sexy anymore, because this is what I hear. It's too baroque, it's too opaque, it's too much. I don't know. But here is my thing. Maybe the next Cyberpunk or Witcher will be in Java. Because if you think about it, what's hard in gaming is rendering. So now we can call, and there are already wrappers for game engines for Java, if you look for things like SDL, for example. So you can start writing your games in Java because rendering will be delegated to C, and then we can basically become all game developers because we don't actually like to write JSON. Let's be honest. Admit it for yourself. You would rather write game than another JSON library. Okay. Thank you very much. I guess we don't have time for questions, but maybe. I'm still here, so you can catch me at the corridor if you want. One question. Do we have it? Nope. Cool. Thank you.
One of the challenges of giving talks is that at the end, we don't have enough time for questions. And seeing that this is a talk about concurrency, let's begin with the questions. So this is a talk about Java concurrent, the different libraries and so on. What questions do you have? Let's get 3 questions. Yes, go for it. Sorry, how? Graceful ways to handle concurrency. Okay, that's a great question. Let's write that down. So graceful ways to handle concurrency. Thanks for that, a fantastic question. Any other questions? How to not think about concurrency, even better. That's a great one. How to not have to ever think about blasted concurrency. All right, brilliant, fantastic. One more. That's a great one. That's a great one. So, graceful or not ways to kill a thread. So these are great questions. Thanks very much. And what I'll try and do, I'm going to try and answer one now, one in the middle of the talk, and one at the end of the talk. So I'll start in the middle. How to not have to ever think about blasted concurrency. Well, that's very easy. You simply just use one thread, one core, and that's it. Make the entire system single-threaded. And actually, there are some really good applications of that. For example, if you're into high-frequency trading, normally what we do is we have one core that we use, and we use thread affinity to bind that one thread to that one core, and you get very low latency that way. You always have the cache available where you need it, and you don't have to think about it at all. All right, I'm going to take you on a little bit of an excursion. I started coding in Java in 1997, before most of you were born, I think. No, you're not that young, but before some of you were born. At the time, we had a class called Java Vector. It's still there, but it's changed quite a bit in the meanwhile. And it was designed to be thread-safe from the beginning. And in this context, thread-safe means that you can do anything you want to with it, and it's not going to become corrupted. And most of the methods are synchronized, and they're locking on this, so that's on the object itself. But the code wasn't actually correct in Java 1.0. They missed important synchronizations. For example, on the size method. So this is an excerpt from the vector. And we see we've got our element count, and we've got an int size method which returns element count. It's not synchronized. And the idea is, well, I don't care about race conditions on the size. But the problem is, we also would not necessarily see updates. So you could have one thread updating the vector, another thread reading the vector, the element count, and that reading vector would never see the change, ever, possibly, could be cached. This was Java 1.0. 1.1, they changed vector to make it serializable. And the simple act by making it serializable introduced a race condition into the class. How? Well, there was nothing protecting the writing of the object. So it could happen that somebody was writing the vector at the same time as somebody else was updating the vector. So you can get a race condition in the output. They fixed this in Java 1.4. In fact, they fixed both problems in Java 1.4. They made the size method synchronized, which now gives you visibility on the change, They could also have made element count volatile. That also would have worked. But they just made size synchronized. And that worked as well. And they added another method, write object, which just does the default serialization, default write object. And that now solved the problem with the race condition on the serialization. Now, if you try to write a vector, at the same time as another thread was trying to update the vector, one of the threads would have to wait for the other one to finish before it could continue, and we would be blocked, and we ended up with this race condition being solved. All right. However, Java 1.4 actually introduced a possible deadlock. So you might wonder, how is this possible? Well, if you have vector 1, which contains a pointer to vector 2, and vector 2 contains a pointer to vector 1, and you serialize from two threads, vector 1 and vector 2, at the same time, then the one thread will first get the lock to vector 1, and then it would get the lock for vector 2, and the other thread would first get the lock for vector 1, or vector 2, and the vector 1, and this would end up in a possible deadlock. Now, I mentioned this many years ago, and I said this, no one would ever do this, right? No one in their right mind would have a data structure where they would have two vectors pointing to each other and then serialize them with two threads. I was wrong. And there was actually a use case in the IBM version of Java where they did have someone doing that, and they logged a bug. So they fixed that in Java 1.7. Java 7, they have a write object method, and what they do is they clone the array, underlying array, and then they write the fields at the end whilst not holding the lock. So they hold the lock, they get the data, consistent data, they make a clone of the data, and then at the end, they write the fields. So this deadlock goes away. So at long last, we've got a version of Vector which actually works, which doesn't have bugs in it. All right? That didn't last very long, because then Java 8 came around, and they added for each method. And the for each method, again, does an alien method call, where we're calling except on a consumer which we're passing in. And here you can very easily, again, cause a deadlock. If you have a vector which is accessing another vector, or in fact a hash table would do the same thing, and we can get a deadlock. So you can see that this is actually not that easy to get right. And these are classes which have been written by very clever people. They're not, they're not stupid. And still these bugs keep on coming in. So thread safety is quite subtle. And the problem is tests don't always expose concurrency bugs unless you know exactly what you're looking for and you're testing for that specifically. All right, so what I did a while ago, I kept on hearing this thing that you shouldn't write your own concurrency util classes. And that was sort of one of the things is, how can you not have to worry about this so much? And the answer is, well, what exactly was the question? Graceful ways to handle concurrency is to delegate the concurrency to existing classes which have been tested for more than our own classes. So if you need a thread-safe list, rather take a list which has been written already than write your own, because you have a better chance of having something where the bugs have been discovered. So I thought, what I want to do is I want to look into all of the concurrent classes in excruciating detail. And my idea was to make like this massive collection of material looking at every single class. And I didn't actually get very far, because I started with the array blocking queue, which looked like a very simple class. I thought maybe 20 minutes should be enough to cover that. And my teardown of that took 4 hours. It's actually far more complex than I realized. And then I looked at copy on write array lists and copy on write array set. Again, I thought maybe 15 minutes. That's easy. I mean, you make a copy whenever you change it. Big deal. Again, 4 hours. And then I thought, well, link blocking queue, link blocking deck, let me try those. Those together took about 6 hours to get through. So and this is like recorded material, so the actual is far more effort. So I'm not doing it as diligently as I should, maybe, but there's a lot to learn. And the idea is following that you should use what's there, but it's also useful to understand how it works in case you need to write your own. So you can learn a lot by studying what is there. Now, the challenge is that you've got this rule book called the Java memory model, but there's no easy way to know whether that is correct. Now, I live on the island of Crete in Greece, and so yesterday I arrived in Lisbon. I had to fly from Crete up to Brussels, and then Brussels to Lisbon, and then we drove from Lisbon up here. And the driving in Portugal reminds me a little bit of driving on Crete. Just a bit. And I wonder if the rules, if they have rules in Portugal on driving. I know there are rules. I know, of course, there are rules. But if you study the driving, you won't figure out what the rules are. Right? It's different in Switzerland. In Switzerland, if anybody breaks the rules, they may need to go to jail. But here, it's a lot more relaxed. It's a lot more, And so we've got this rule book for Java memory called the Java memory model, which says exactly how things are supposed to work. But the problem is we cannot test whether a class adheres 100% to the rule book. We run our code, we hope it works correctly, but some of these debugs are very hard to detect, and they might only show up on certain hardware. So I was looking at the lock support class, and I noticed there was some really weird code going in there. And there was, in different places in the JDK, there's this block. It says static block. It says class ensure loaded equals lock support.class, and it says here prevent rare disastrous class loading in first call to lock support.park, and the link to the bug. And I tried for a while to figure out whether this actually still is a problem, right? Because it was a problem in Java 7, but even at the time, it was extremely difficult to diagnose and discover. And the person who diagnosed it and discovered it worked for Google, and he actually had to run for 1 week of CPU time to find one instance of this problem. So you might say, well, if it's such a rare problem, why do we care? Well, because it could cause a deadlock. So we don't want to have a class loader deadlock in our application server, even if it only happens very rarely. We must avoid that. So it was very hard to actually figure out whether or not this still happens. Apparently, it doesn't happen anymore with the normal class loaders in Java, because things have changed. Nowadays, you use the concurrent hash map, and that ensures that lock support is loaded. But I couldn't find a conclusive answer, yes or no. So quite often, these bugs that you find are very rare and hard to discover. So what I thought is it's a good idea to study what's available and to use existing classes as much as possible rather than write your own. And studying them is helpful also that if you do need to write your own, you have some idea of how to do it. Now, we all make mistakes when we code. Even AI makes mistakes sometimes. And so we want to have good tests. But with multi-threaded code, it's more difficult because it's happening concurrently. Now, there's a framework called Java Concurrency Stress Test that can help you to write good concurrency tests. But also a good idea is to rely on well-known synchronizers. So if I need a thread-safe map, I've got 3 options in Java. I've got the hash table, which is a very old class. I would not recommend that. It's very slow. It has contention on read and on write. We've got concurrent hash map, which is very widely used. And then there's concurrent skip list map, which is not as widely used. So I say because concurrent hash map is more widely used, rather use that one if you have a choice. If you need a queue, rather take link blocking queue instead of link blocking deck because it's more widely used. So take whatever's more widely used and use that. I started reporting bugs quite a while ago, and I've found a few. I found one in concurrent skip list map. I found one in arrow blocking queue, 2 in link transfer queue. One was quite recent, actually. And then 5 in link blocking deck, which we've all fixed in Java 26. And so what you find is that the less used the class is, the higher the chance of bugs. And sometimes these things can stay undiscovered for a very long time. So another thing I looked at is where do these classes, where are they used within the JDK? You know, eat your own dog food. And so concurrent hash map is used hundreds of times. So that's a good candidate to use. If you need any concurrent structure, take that one. Then in terms of other classes, copy and write array lists is used quite a lot. Concurrent linked queue, concurrent linked deck, future task, and link blocking queue. And link blocking queue is also used for the fixed thread pool. That's what uses it underneath it. Then we've got the countdown latch, is not used as much, array blocking queue, synchronous queue, concurrent skip list set. So it goes down and down, and once you get to the copy and write array set, it's not used anywhere in the JDK as far as I could find. So you want to try and use the ones at the top rather than at the bottom. And rather use the extremely common classes than the very rare classes. Oh, before we continue, I've got a little gift for those here. That's a coupon for a data structures course, which has a lot of concurrency in it as well, because of course the data structures, some of them need to be thread safe. So if you go to tinyurl.com/JNation2026, you can get that. Now the coupon expires tomorrow, so you need to get it before tomorrow. But once you've got it, then you've got a lifetime access to the course. And that's a QR code if you want to not type in the URL. So you've got lifetime access, but I always recommend to try and finish it before, end of June, for example. Set a target so you actually finish it. All right. So I want to look at a class called Stripe64. See how it works, and then actually look into the details how it's actually implemented. And here's some code we're going to do. Stripe64, and let's go to demo quickly. So I've got over here, first of all, I'm going to go 100 million times. In parallel, I'm going to increment this number. So I'll put this into a timer here. It'll be atomic time, and let's run that and see how quickly that completes. So I've got 12 threads at the same time that are trying to update this shared atomic long. And it takes just over 5 seconds. Is that good? I don't know. It's 100 million, it's a lot. So let's put this into a method. So put this into a method over here, test atomic. And I wanted to do it a couple of times to make sure that it's warmed up properly. I won't let it run through. It's a bit of a waste of time, but I'll do it a couple of 2 or 3, and then we'll go to the long adder. So 5.4 seconds, atomic time. And, it's actually gotten worse. Normally, when you run it for a while, it warms up. Here, it's cooling down. So that's about 6.2 seconds for the atomic time. And of course, what can happen is, because it's a laptop, it tries to preserve power. And if you're heating up the cores too much, it actually might slow them down, and you might have it running slower. All right, so that's the atomic, 6.2 seconds. Now let's do the same thing for the long adder. We're doing exactly the same. We're also incrementing 100 million times in parallel. And we'll put a time. This will be the adder time. So this is a different construct. And look at that, 120 milliseconds. So that's already 50 times faster, just off the bat. And let's put this also into a method. Test adder, it's a long adder. And we'll put, do it 10 times. And we'll see how, if it warms up, if it speeds up a bit. So this actually speeds up, if you run it a few times. It warms up, and it actually gets down to about 60 milliseconds. So it's about 100 times faster doing it with long adder rather than atomic long. And of course, these results will vary depending on what hardware you're running on. If I take the same code, I run it on an Intel machine, I'll have different results. Run it on a Linux machine, I'll have different results. All right, so how does this work? Well, it works like this. With atomic integer, or atomic long, it does an unsafe get and add long. It does a compare and swap. It does here compare and set long. And it tries to set it, and if there's a clash, it simply tries again. So it's just one field that all the threads are hammering and getting possibly clashes on. With a long adder, the way it works, when I say increment, it says add, and this is a lot more complex. It actually starts by taking a variable called base. So this is the base value. And if there's no contention, it's only going to have one field inside the long adder. It's actually subclass of stripe 64, that's what it's using. It's going to have one field, but it's going to update just with one thread. So this is very, very simple. Okay? But if I have a compare and set on that, and one of the threads loses the race on the update, then that's a detection that there is contention on this field, and it then makes an array of cells. So these cells here also have values inside, and they've actually been marked as contended. This is an internal flag which says that the objects must be larger. So what they do is they make the cells bigger than normal would be 24 bytes for the cell, because it's an 8-byte value, 12 bytes, 20, 24, round up to 24. Or 16, depending on what you're running on. 16, 24, or 32. So any one of those can happen. But with contended, it makes it another 128 bigger, so that each cell lives in its own cache line. Cache line is normally 64 bytes, and so they make it bigger so that we don't have cells next to each other living in the same cache line getting false sharing and true sharing. So it now makes 2 cell objects, and each thread will update its own copy, hopefully. So they try and share the threads between the cells to reduce the contention. If you have another failure, then it will double the number of cells again. It'll keep on going up until some upper limit. So for example, if you've got 12 cores like I have, it's going to go up to 16 cells, and then it won't make it bigger after that. And so this is why you get such good performance. Now, it's a flexible construct in that if you don't need additional cells, if you're actually using it in a single-threaded environment, it's only going to have the one field. But the moment that you have clashes, it expands it. There are other classes in the, there's a thing called JC Tools, I think it's called, where they've got a counter which has a fixed number of cells. And that one is faster than the long adder because it doesn't expand. So it's simpler and it's faster. But this is going to be really fast for most cases. All right, so this is our long adder. And it's not magic. We've had a look at how this works. Long adder, and there's another one called long accumulator, are based on stripe 64, and it expands the size of the number of cells as you have clashes to reduce the contention. And basically, when you have contention, the best way to deal with that is to get rid of contention completely. Not to say, well, let's take synchronized or atomics. No, try and reduce contention completely, eliminate it. That's the way you get the best. All right, I mentioned to you that I'm really old. I've been programming in Java for 100 years, almost. And when I started, my machine, I didn't have a laptop, my desktop had 64 megabytes of RAM, single core, of course, And I think it was 233 megahertz. It was a Pentium something, I think, Pentium 3 or something. And 32-bit. And that was one of the better machines in the company. And the other programmers were using Oberon and C, and we were like using Java. And we were complaining our machines are too weak for this. And people were saying, come on, it'd be ridiculous. This is, you've got the best machine in the company. My laptop here has 96 gigabytes of RAM. That's 1,500 times more than I had then. 12 cores, 3.7 gigahertz, and 64-bit. So at the time when they wrote Java, memory was very scarce. I couldn't imagine creating a collection that would have billions of entries. And we only had platform threads, right? So there you're limited to hundreds, maybe a few thousand of threads. But then a lot has changed. Nowadays, we can make very large heaps, terabyte heaps. And we can also have a crazy number of threads, millions of virtual threads. So there's a bug that I discovered in the link blocking deck that allowed us to fill it with too many items. We actually overflowed the size. So this was a bit of a trick. Basically, when you construct the link blocking deck with another collection, you can pass in a collection that's bigger, and it actually will then overflow it. So I've got a newsletter on that if you want to see how to do that. So that's fixed in Java 26. There's another one which is interesting with reentrant read-write lock. With the reentrant read-write lock, you can have write locks and read locks. Only one thread at a time can have a write lock, but we can have a lot of threads at the same time having read locks. When they wrote it, they made it so that you couldn't, they basically stored the number of read locks, number of write locks in 16-bit numbers. So they took an int and they broke it in two. So watch what happens if I take Java 24, for example, or let's take a really old version of Java, like from a very long time ago. Let's take Java 21. Anybody still using Java 21? No, surely not. Okay, and I take source main Java, demo, and we're going to take demo 2, and we run it. And what happens is it actually throws Java-lang error. Once you go past 65,000 threads, which is easy to do with virtual threads, it throws an error. So they fixed that in Java 25. So it'll just say, okay, fine. They changed it to long. So now I've got 2 billion threads on both sides. So it's plenty of threads available. But you will often find these bugs at the extremities, at the limits. That's where you'll find these bugs. Race conditions dead. Create your own class. Now, I want to make a starting gun synchronizer. And the idea is depending on this one service. So they should all wait until I'm done, and then they can start. But what I don't want to have to worry about is interrupted exception, because it's messy and I don't want to see it. So that was actually one of the questions was about the stop. How do you shut down? How do you stop a thread gracefully? And so nowadays, when you want to shut down a thread, it always has to be cooperative, but normally you do it with interruptions. The interrupt indicates that you're trying to shut down. Although that's not what it means, that's how we use it most of the time. All right. So I've got my starting gun to take, is to use synchronized and wait. Synchronized and wait. So basically, I make my Boolean ready equals false over here. Let me take my amazing pointer. False, I put it into local variable. That also clears the status. So after I've done that, after I've called that, it's no longer interrupted. I then say, while I'm not ready, I call wait, and wait lets go of the lock, and now other threads can get into that method. And just to note that wait is not fully compatible with older virtual threads. So before Java 24, this would have caused a problem. But after Java 24, it's fine to do this. If I get interrupted, I'm going to note that, but keep on waiting. until I'm finally out of the wait. Once I'm ready, if it's interrupted, I'm going to reinterrupt my own thread and leave from there. So this is my wait, and then my... So this is a correct way of writing it, although correct is a bit dangerous because in Java 21, this wouldn't work well with virtual threads. Another way to do it is to base it on an existing synchronized like countdown latch. So I make a countdown latch of size 1. Again, I do the same type of code where I wait until I'm done, and then ready will say latch.countdown. This is a bit better because if there's any problem with the logic, and the logic is inside the countdown latch, then once that is fixed, this will automatically be fixed. So it's better to rely on existing classes which have been debugged as well. Plus, this will work. Now, we try to hide it, but we're still going to pay the cost of creating the exception unnecessarily. Another way to do this is to copy what countdown latch does. So we can actually do that as well. We can go here and we can say, let's have a look at countdown latch. And what I want is to copy the sync class, the inner class here. I'm going to copy that in here. It's my own little sync. Oh no, I've copied the wrong thing. Let's try that again. Come on. I was there. Countdown latch. Copy. That's one thing I've forgotten how to do is copy paste, you see. So this is an abstract queued synchronizer. And then if I look at the going back to the countdown latch, there's a method called await, and inside here it says sync.acquire shared interruptibly. So I'm going to do that same here. I need a sync. I'm going to say private final sync equals new sync of just one permit. The normal countdown latch has a flexible number of permits, or whereas this only has one. And then the other thing I need to do is the ready, which again we're going to copy and paste from countdown latch. And here we're going to say the countdown method is basically going to be the same as our ready method. So we put that in here. And because I don't trust myself, I've written a test to make sure it's correct. And I'll run that quickly. So that's my, and it works, all right? So what I've done now is I've made it that I no longer throw this exception. Instead of using release shared interruptibly, or release interruptibly, or whatever it was, no, sorry, acquire shared interruptibly, I now just say acquire shared, and I'm basically copying the approach from countdown latch, but with a better interruption mechanism. Which is the best? Well, I tend more towards a second approach, where I'm basing it on the countdown latch, so I get all the benefits. The only thing is I have additional exceptions being constructed. All right, let's have a look at something else, the link blocking queue. So this is a very interesting class. It's a class where you've got a concurrent type of queue. It's built with linked objects. And what they've tried to do is to make it as efficient as possible by having two different locks. One lock is for putting, and one lock is for taking. And so if they had one lock, then put and take would cause contention between each other. But because we've got a put lock and a take lock, these are both reentrant lock, I can actually put and take from the queue at the same time. And if I've got a single producer, single consumer, then I can get higher throughput than a queue which has one lock for putting and taking. All right? But we might see some surprises when you've got multiple consumers and single producers. I'll show you an example of that now. Also, because I've got two different locks, there are some subtleties to do with the visibility of the data. So the way that they do that is they use an atomic integer as a synchronizer to give visibility on the memory. And so whenever they change the queue, they also update the count, and that will then give a thread which is reading the count the visibility on all the changes which have happened on the queue. All right, so let's look at a demo here. So this demo I wrote, and it's what I'm doing here is I've got a number of consumers and a number of producers. In fact, I've got one producer and several consumers. I've got a link blocking queue, and then I've got one thread which is putting elements into the queue, and as many consumers as I specify, which are going to take elements out of the queue again. So one puts them in, and number of consumers takes them out. And then I measure how long it takes to do this. So I'm going to start with a link blocking queue, and you'll see that it's going to be fairly quick, and I'm going to do it with ZGC. No, I don't want to use ZGC. I want to use, I'll use ZGC. So you can see it's like 800 and something milliseconds. So the best time here was 877 milliseconds. So it's pretty, I think it's pretty good. I don't know if it's good or bad, but it looks pretty good. Let's try the link blocking deck. Now the link blocking deck has a single lock that it uses for put and take. So what happens if I do multiple threads, putting and taking at the same time? Okay, it's a little bit slower, but 30% slower. It's not a big difference, but it's a difference. Okay? Let's take the array blocking queue, which again has a single lock for put and take. All right? And well, that's actually quite good as well. And the reason why is, if you look carefully, it uses a lot less memory. So a lot less objects are being made. An array-based structure is going to be the most efficient way of arranging objects. So it's fairly close to the link blocking queue, even though you've got contention on the one lock. All right, now let's change this a bit. We're going to now take a link blocking queue again, but now we're going to change the number of consumers to 2. So one producer, 2 consumers. Now watch what happens. So the link blocking queue now has no contention on the putting, but it does have contention on the taking. So you can see this, the taking has a fairly high system time as the threads fight over the lock. So the 2 threads are fighting over the rented lock to get the values out. So you can put it in, but the taking out is taking longer. So it actually slows down when you've got 2 threads, and the 2 threads reading it out. If you take the link blocking deck, here we're split between the one producer and the 2 consumers are all containing on the same lock, and so it actually is keeping up with the producer. And so you can see the performance is actually quite good. Much better than the other one. And then the link block and the array blocking queue is similar. It's also about 300 milliseconds. So it's quite a bit better. So you might say, well, I mean, how many of you have ever used a link blocking queue? One person at the back. Has anybody ever used a fixed thread pool? Yeah, now you get a whole bunch of hands. So the fixed thread pool has a task queue, which is a link blocking queue. So if all of those who put up their hands a second time around have used the link blocking queue. And this is where it gets interesting, because if you make a fixed thread pool of size 1, what you've got is you've got one consumer, and if you have one thread putting jobs into the fixed thread pool, you've got one thread putting them in, one taking them out. And if you then have a very small task and a fixed thread pool of 1, there's a good chance that that will actually run faster than if you make a fixed square pull of 2. And the reason is exactly this, the contention on the take. All right, a couple of other classes. The array blocking queue. Now this is quite an interesting one. Array blocking queue is based on a circular array queue. So it's like an array deck, but thread safe. And it's got weakly consistent iteration, which means whilst I'm iterating, if somebody changes it, then I might see the change, or I might not see the change, but I won't skip over elements and I won't see the same element twice. So there's no guarantee I'll see all the changes. So there's certain rules about this. So for example, if I make an array blocking queue here of size 10, I put in 5 elements, I make an iterator, and then I show 3 elements, I'll see 1, 2, 3, and then I add another 5 elements, I will see the rest of the elements as well. So that's what we see by weakly consistent. If you did the same thing with an array list or with an array deck, you'd get an exception when you try and continue iterating. You get a concurrent modification exception. But what happens if you circle completely around the array and overwrite the elements that are there? With the linked blocking queue, that's fine because you simply add more nodes and everything's fine. You start iterating from the beginning. But here you can't. So somehow they actually need to have a pointer back to all the iterators which are currently busy, right? So it's weakly consistent, but they also need to track existing iterators. So what they did was they've got a bunch of weak references pointing to these iterators in order to not have a memory leak. So if we look at that, that's number 5. We've got an array blocking, the link blocking queue over here, for example. What I'm going to do is I'm going to iterate over them, and then I'm going to loop around. So I'm going to add a bunch of elements and remove them again. And if I take the linked blocking queue here, what you'll see is that it shows 1, and then it shows the remaining elements which are inside the linked blocking queue. But if I do the same thing with the array blocking queue, we'll have slightly different results. We don't see the remaining elements because the iterators have all been invalidated. And the way that they do this is inside here, they've got an iterators class, and the iterators class tracks all of the iterators inside weak references. And the reason for that is that if you go to the end of an iterator, all's fine, but if you start using it for a while and then you stop using it, then, and it goes out of scope, it'll be garbage collected, and then we don't end up with a memory leak. So it's the funny thing is weak reference has nothing to do with weak iteration as such. All right. Another interesting little class is a copy and write array list. And what they do is they make a snapshot, or rather they, whenever you change the array, the copy and write array list, it makes a copy of the underlying array. So if you change it, it makes a copy. And so it's very expensive to construct, to add lots of elements to a copy and write array list. Let me show you a demo of that quickly. So I have now cow demo over here. And if I do this, if I say var list equals new copy and write array list, and I go 0 to 20,000 list.add I, it's going to take a bit of time to do this. See, my timer is up, so I'm not going to be able to run this for too long, but we should be able to get through this bit. So 20,000 items, 66 milliseconds. All right, let's make it 40,000. Oh, that's quite a bit more. 80,000. Every time I double it, it becomes quite a bit slower, so it's 660 milliseconds. Do it again. Now it's going to be close to 2 seconds, or 2.3 seconds actually, a bit more. Oh, yeah, of course, 2.3 seconds. If I did it now to 320, it would be that times 4, it would be about 10 seconds to run that. So quite bad. That's because every time you add it, it makes a copy of the underlying array. There's an easy workaround for this, and that is to make a temp array list and to put it into temp and afterwards say list.addAll of temp. And now it's going to be linear rather than quadratic cost, and so it's very, very fast again. So what's interesting is the remove method, because they try to avoid synchronizing within that. So they do something called double check locking. What they do is they do a snapshot where they just get the array, put it into a local variable. They then look for the item in the range. If they discover it, then they call remove a second time with that index. And look at that code. I have to show this code to you. It's quite funny. There we go. Remove. Here we have. They check whether the snapshot is equal to current. If it's not equal to current, then they go and find it. But look at this. If snapshot not equal to current, then they've got a labeled on the if statement, on the code block. Now you might wonder, why would anybody code like that? You know, that's horrible. However, there's a good reason why, and that is they try to write the code in such a way that the code can get optimized well by the hotspot profiler, and we don't always have that information ourselves. So I want to just quickly go back to the beginning. I think I have answered this last one as well, which is how to kill a thread. So killing a thread is basically stop. Okay, so what I want to say about stop is thread.stop comes from the precursor to Java called Oak. Oak was a language before Java. And in the Oak, they had this idea of an asymmetrical exception, or asynchronous exception. And basically, your code is running, and in the middle of execution, it can be sent an exception from another thread. And that's how it was implemented. You could actually, in the past, send exceptions to any thread, any exception to any thread. So thread.stop used to take an argument, and it would just simply, in the middle of any code, just die, right? And so that's obviously dangerous, and they changed that. So nowadays we do it mostly with interruptions. And a very nice mechanism to manage all of this is structured concurrency. Now that's still in preview. It's probably going to be available in Java 29, I think. If you're not on my newsletter, you're welcome to join. And just this is that gift I gave. Are there any more questions? We've got another 20 seconds if you have a question. I'm going to be here for today, so if you'd like to chat, please come around. I don't bite. I just don't speak Portuguese, unfortunately. Thank you very much.
So, hello everyone. A little. I'll just thank you everyone for joining me. There is a slight delay on technicalities. It happens. How many engineer we need to fix the slides, right? That's the kind of jokes. So again, thank you. So this is the presentation. What I'm going to share about some things about Java 25 and how it became, how it is in this time, like when everyone is writing code with AI. So I have like 2 slides for AI, but it's definitely not an AI presentation. So hopefully you'll be with me. So all right. Now the first thing is, that's the 2 slides basically. I'll just talk a little bit about AI, because we are all kind of writing using AI to generate code. So first question I have for all of you, how many of you essentially use agents like Cloud Code, Codex? Okay. Not too many. So that's interesting. Okay, I thought everyone nowadays writes code with AI. I mean, some sort of agents, Copilot. Okay, I do write, use AI a lot. So now the highlight is obviously with the code generation is getting cheaper a lot day by day. But then this is where the bottleneck is getting. Previously, we had to, spend a lot of time writing code. Now it's cheaper. It's just, in a blink of eyes. But then that's where the problem is, because we eventually have to understand the code, right? Do you agree? Okay, it's a light presentation. The previous one was, it's a complex concurrency stuff. This one is pretty lighter, so you can interact with me. Anyway, moving on. Even though we are producing code a lot with AI, but we still need this, right? We need correctness, maintainability, security, debuggability, all of those things. And for those, as an engineer, we have to understand. And if we produce a lot of code, as a human, we definitely cannot compete with machine in terms of speed. So that's where the bottleneck is. So we have to understand. And there's another thing that I want to share with you all, which is previously, when we used to write code, we were much more involved, right? In the process. Like, every line of code we used to write by ourselves. So it has a mental attachment with it. And when we used to create a pull request, we already have enough judgment, before raising the PR. But nowadays, it's super faster. And AI produce a plausible code. It looks really interesting. I mean, it has all the edge cases, test cases, everything. So, we often just pass it, try to pass it, that it looks fine, so it's probably fine. But that's where the problem is, right? That's where subtle bug gets into. So that's why I personally feel that understanding code is getting expensive. All right, so this slide is essentially says the same thing what I have just said. Now, keeping all that in mind, how is the situation of Java in the 2026? Do you know which version of Java we're currently running? Okay, it's 26 currently, but 25 is sort of LTS. And I would like to ask this question. How many of you are using 25 right now? Okay, I'm using 25. Anyone? Okay, how about 21? Okay, so majority is sort of 21. Okay, that's good. All right. So anyway, Java has gone, many years, like it's 31 years old by now. So when I go to the conferences and meet peoples, I see some sort of, voice like this. Java is pretty old. It doesn't evolve as much as it should be. Some other programming languages, for example, Scala, Kotlin, Go, Rust, they're doing fantastic job. For example, Go has a Go routine. Scala, Kotlin has expressiveness. They can do, pattern matching. Rust has like amazing capability of netting interrupt, all of those interesting functionality. But what about Java? It's pretty old. I mean, it's been doing same sort of concurrency for a long time. It has like platform threads. It doesn't scale. It doesn't have this kind of conversation I hear a lot. So that's the basically what I'm going to do is debunk with all the new features that we have right now. So bear with me. This is essentially the question of my entire presentation. Just read it. Basically, the idea is Java reacting in now, or it just gradually evolving with the maturity, thought process, all of those things in mind? So that's the fundamental question that I'm going to asking, and then I'll show you some demo. That's the goal of this presentation. All right. So this is basically where I'll shift, slides and presentations. is that Portuguese write-up is correct? Okay, perfect. All right. So do you know that you can write code like this, in just one file, and you can create a main method, and then also write text like how you do in Python? So that's JDK 25 essentially. So if I run this, I'll get something like that. All right. So I have a lot of small demo as we go along. All right. So first thing that I'm going to talk about, which is expressiveness, right? So when we're gonna write a code, let's say this is the code that we want to write a class that's person, and it has like 2 fields, and we need to access those fields, right? We need toString, we need hash code, we need equals, all of those things. But those are essentially, what we want essentially a data holder. Like 2 fields that it holds, and that's all we want. But to achieve that, we need to do, speed a lot of those things. I mean, ID used to do that. Now AI can do that. But then again, a lot of ceremony over the intent. Our intent is just two data holders. So that was the old Java. Now, with the latest Java, we have all this. We have records, we have CIL types, pattern matching. Records actually, reduce all these boilerplates. We can write this in a one-liner. And CIL types, we can have closed hierarchy, and we also have pattern matching. So these are the things, these are the features of modern programming language. Scala has, Kotlin has. I don't know about Go, but some other programming, Rust probably have a little bit. So what I'm gonna do is, I'm gonna show you some of the languages that how they deal with this. So that's the first thing that I'm gonna do. Moving on. Before showing all of those things, I want to, sort of give you an idea what is the challenges that we had in Java previously. So do you see any problem in this code? It's pretty simple. Like, it's a if conditional. If this is a circle, we're going to do something. If it is, rectangle, we're going to do something else. And have you seen in production code, like, 15 layers of these if blocks? I have seen a lot. So what we're doing over here is basically we are checking the instance of if it's a circle, and then we're casting it. We're basically verifying the type and then casting it. And then we also extracting the value from there, and then we are doing the conditions. So we are doing a lot of things, basically. This is fine. I mean, we have been writing code like this a long time, and AI can also do that. For a 5 if blocks, like when you were in a production code, you have something like that. For a first iteration, it's fine. Maybe it's also fine when you were in a 5th iteration. You have added new things. It will not break the code. Compiler will be fine. This is also good. But when you are in a 20 iterations, it's going to be difficult. Even the compiler is going to be fine if you write code like that. But then subtle bug can introduce in this, and you have a lot of code coverage and whatnot. So these are the things essentially we need to take care of it. So other modern programming languages they decided that this sort of problem we need to deal with, maybe we shift the responsibility to developers to the compiler, from developers to the compiler. So the idea is that if you make a mistake, or if you miss any cases, compiler will give you the warning, or even it doesn't compile. So that sort of things we, other modern programming languages sort of come up with. So we're gonna see first, Scala's approach, how Scala does that. So over here, as you can see, we have let's say, a CIL trait that is a shape, and then it's a case class, essentially, this implementation. The idea over here is, shape has 2 subtypes, essentially, right? And all of them probably in the same file. And case class, essentially, is that it has everything. It has field, it has toString, getter, setter, all the things in one line. So you can access all of those things. And how we're going to use it? You are going to use it like this. So let's say if I want to calculate get area, over here, as you can see, since you wrote as match, your pattern matching comes up, and you create a case class in the circle bracket R. So what it does, it checks type, it's verify, and also it extracts the value, like R, and you are going to do something with the R. So all of those things done by compiler, and if you made a mistake, or let's say if you forgot about one subtype, it will definitely catch immediately in compile time. Similarly, Kotlin does that same things over here. It's a slight different syntax, but it's ultimately same thing. You have a seal class, and then you have a data class. You get this, when you write the when, your pattern matching start, and if it is a is circle, you can immediately get into that branch. And also it covers like type checks, smart cast, all of those things. Like I'm gonna continue. This is the Rust, and it's probably the extreme example, but it pretty much does the same thing. What I'm trying to say is, we have seen this in some of the modern languages that we are really excited about. For example, Scala, Kotlin, Go, Rust. But does Java support all of those modern language feature? So that's the question I have for you. And interestingly, if we see in Java, in fact, Java has all of those features now, right? For example, it has a sealed interface, sealed class, and it has additional, extra keyword which is permits, so that you can. So the idea is this sealed interface shape can only, extend. Only subclass we can have, which is circle and square. And then you can have records. Records is basically the data class of Kotlin, or case class of Scala, same things. So how we're going to use it? Well, it's pretty much the same. You get a method like that, and then you're going to do pattern matching inside a switch. So S come in, and then you have a case. Over here, as you can see, we already extracting the value from the circle, var. It calls record reconstruction. So we don't even have to specify the type. So we automatically get R, and then we can do something with it. And now, what if tomorrow I have introduced a new shape? It could be we have triangle. If we introduce that, the compiler immediately stop you, that you haven't take care of that here. So you have to compiler automatically check the exhaustiveness. So that's how it becomes expressive nowadays. I have some demo code I'm going to show you. So the idea is Java sort of. Now question is, did Java copy any of this from the Scala, Kotlin, or other language? My take is it didn't. It rather evolved evolved. It definitely see the ideas in other programming languages, but it kept on the familiarity of Java ecosystem. As a Java developer, let's say you haven't done any Java code last 5 years, if you come here, I would not say you see something completely different. Rather, you will see the same familiarity. At the same time, we are achieving similar functionality that modern programming languages have. So this is I'm going to show you the demo quickly, but this is what happens. Like, if you introduce a new type, let's say triangle, and your compiler will automatically, point that. And interestingly, even though we are doing AI now, producing code, it's also, helps AI as well, because after producing code, immediately you can run it. If it runs, at least you have got confidence that it works. Now, probably I have to run the test cases and also rigorous review. All right, moving on. So I have a demo for that, but before demo, I have a giveaway for you. I have a copy of a book that I definitely want to give one of you. I only have one copy, sorry for that. So you can just take a QR code, then we'll do a lottery end of the presentation. Just take a screenshot quickly. Okay, so moving on. Now, are you good with the expressiveness? Are you confident that are we sort of in agreement that Java has the modern functionality, like Kotlin, Scala, and other programming languages has. What do you think? Yes or no? OK. So I understand it's pretty much end of the session, and you guys are tired. But anyway, so now we have sort of get those functionality. OK, so before going that, I am supposed to show you the demo, right? I forgot about that. So over here, you can see the code, right, from the behind? OK. So over here, I have a code. This is the method that I'm going to run. So as you can see, we have a next step. This is a pretty old way of doing things. Let's say you get an event, and based on event, you are going to take some decision. Like if it is a instance of initiated, then you are going to cast, and then extract the value, and then do some code over here. And also, it might have other if else block. What if if you introduce something else here, new type of event, it will not be here. You might forget. So that could might throw an illegal state exception or something. Or if you don't have else block, it might not even work. So now this is a modern way of doing things, which is the Java 25 version, which is a pattern matching. Although pattern matching come earlier, I'm referencing 25 because 25 has all the features. That's why I'm saying 25, but pattern matching came way earlier. So over here, I have an event. It can be payment event, and then I will have a lot of cases over here. You see, even when let's say case initiated, and initiated it's a record, and it has two fields, payment ID and amount. And over here, let's say I'm only interested about amount, not the payment ID. I can ignore that variable altogether. So it's called unnamed variable. You can just use underscore over there. So that's removed from your eye. So you don't have to worry about that. And now, so I have a sealed interface over here, which is payment event, and it permits like initiated, captured, refunded. Now let's say tomorrow I'm going to introduce a new payment summary, and I have to add that. So I have payment event, and I have over here, payment summaries. So let's say I have introduced a new type, new event type. As you can see over here, it's already complaining. It's saying that Swiss expression does not cover all possible values. So your code will not compile. So you will have to sort of add that case over here so you don't forget. So this is how it's remove the subtle bugs. Anyway. So these are the modern version. It's pretty concise. It's like few lines of code. But if you use old version, you will see it tons of, it's much longer compared to this one. So these are the new features essentially. Anyway, so now, OK. So we have covered the expressiveness. And what about the performance and skills? Does it, can you compare with Go, Routine, or other programming language in terms of concurrency? So I'll start with concurrency. So right now, we before JDK 21, we have like two way of doing things in Java. One is we have a lot of platform threads, and how platform threads works? It is essentially in Java a one mapping with the operating system thread, and operating system thread limitation. We cannot have as many as we want. Now let's think about the web applications. You want to increase the throughput, like you want to serve a lot of users, and you have like limited number of threads. So you are bounded by the number. You can scale as many after a threshold, you will not be able to create as many threads as you want. So concurrency is sort of limited. So that's called scalability wall. And then there is another option, which is nice, reactive programming. This is also great. I mean, a lot of production codes are written with this. But the problem is that with reactive, it scales well, it solves problem, you can high throughput, but then the code become really hard to maintain. Have you written any code with the reactive programming? Anyone? What do you think? Do you agree or not? All right, so these are the two problems we had earlier, before 21. Either we'll have a scalability wall, or we have a complexity trap. And it's really difficult, especially if you want to onboard a junior programmer on your team. If you want to explain reactive programming, you have to give a lesson on functional programming, a lot of things. So it's a difficult thing. Anyway, so in JDK 21, Java comes with a new way of doing concurrency called virtual threads. The idea is we have platform threads, basically the classic threads. And on top of classic threads, what we can do is we can create a lot of JVM threads, which is tiny little virtual threads. We call virtual threads. And this thread works like regular threads. As a developer, when I'm going to interact with the virtual threads, it looks exactly the same, but then it doesn't, it doesn't have a mapping with operating system thread. It's rather on a JVM construct. We can have millions of them and work exactly same way. So if we have a blocking operations, we can just create a new virtual threads. So over here, let's say I want to create a virtual threads. I can do something like that, thread start virtual threads, and we can pass a argument. That's it. It's going to create a virtual thread over here. And if I want to get the reference of it, it's remain the same. It's exactly the old way of doing things, threads. From a developer perspective, nothing changes much. It doesn't change much. We can rationalize the same way earlier, but it's a lightweight version of threads. I have written a lot about it on this book. So if you are interested, you can sort of read it. And if you have executor service, you can do like this. Var executors new virtual threads. So it will be like this, and then you can, in the executors, you can submit your runnables or callables. So it's exactly the same. So if you have a lot of codes under the executors, you can just change one line and it will work the same way. So, so the benefit is, as a developer, I don't have to unlearn I don't have to learn a lot of things. I can remain my similar understanding of concurrency, but then we can get benefit of way a lot more concurrency. We can create even virtually millions of virtual threads using this. So it doesn't change much. So now, can we compare with Go routines? I think the outcome is similar. Like Go routines also serve the same purpose. So virtual threads pretty much serve the same purpose. So that's the new edition. Pretty much, I'm very interested. I'm using in production code, to be honest. All right. So now, next thing is, scale is pretty much solved. What about the safety, right? So that's where we have, let's discuss this problem over here. Over here, let's say I have executors and I'm submitting a function, face profile, and then 3 others. And one of them, throws me an error, like profile get. But my result depends on all of them. So I have spun like 3 threads, 3 virtual threads, or 3, if we are using the old way of doing things, I will probably, get 3 threads from the thread pool. Now, get profile, throws an exceptions. Now, whole things I have to throw it out away because I don't have the whole three things, and my result, final results depends on all of those three. So what happens is profile, this thread will be killed, and in the behind, in the JVM, the previous two will be keep on running. So they doesn't serve any purpose, but they will still be running. So that's another problem. So what, there is a new concept in Java. It's coming along. It's in still preview version, but you can experiment it with it. It's called structure concurrency. It's give you a structured parent-child relationship between threads. So let's say I have a parent thread. I am starting 3 subtasks, and I might have a relationship like that. If one of them fails, I want to fail whole things. Or I have 3 subtasks. I want to get the faster one. If I want to, if I get the result fast with one, I'll ignore rest 2. So they will be, removed from the, executions. So that's the idea of, structure concurrency. I have a demo for that. So the first one is essentially, does like this, all or nothing, first win. You can sort of combine multiple ways, like hundreds of ways. You can do that. So you will write code like this. You will create a scope, and then scope you will just fork. This code is pretty simple, but then it's create a structure in your code. All right, let's say I have a demo over here quickly. So let's say I have this demo. You can see my code, right? So this is the code over here. As you can see, I have executors over here, and this is a fetch profile, and then this is the fetch performance, and then these are basically some dummy method I have written, and this is the fetch risk, and then we are calling profile.get, which might throw an exceptions over here. So I sort of throwing an exceptions over here for the purpose of the demo. Now, let's see what other method does. It just, let's see, like it just print a line. So we are doing some work over here. Now, I'm going to run this demo 2. As you can see, first one is actually we have an exception over here, but the other two still, they were running and they get result, which we don't need it right now because our whole result depends on all 3. So if we rewrite these things with, structure concurrency, so what we are doing over here, profile task, performance task, we can do another one, which is risk scope dot fork. And then we're going to run it. Let's see what happens. As you can see, the first one, it's an exception because manually, this method actually throw an exception. So as you can see, there is no other result over here because all of them are now went away. So that gave us clarity. It doesn't pollute our log as well. So these are the benefits. So it gives some sort of structure in our concurrency as well. So this is a structured concurrency. So this is kind of a great things. I think Java has this. I don't know if many other programming languages has this structured concurrency like Scala or Kotlin or even Go. I don't know if they have that. I think they don't have it yet. So in that case, Java is great. And then final thing is native interoperability. So sometimes what we want is, let's say, we want to execute some native methods. Let's say for some machine learning or some interesting reason, we want to execute some C code that's really well written and highly performant. No point of writing same code in Java. Maybe we can just use it. So there is no way of doing things. In other programming languages, Python, Rust probably have a better way of doing things. And the reason machine learning in Python is very popular because Python can easily wrap C functions, C++ the functions in Python, and everyone thinks it's Python. But under the hood, it's basically something else. And we had options, which is JNI, and it's extremely brittle and terrible. We don't want to use it, and nobody wants to use it. And I think pretty much everyone hates it. That's problem also solved. Now we have things called Java foreign function and memory API, which is pretty simple. We had a session over here about this, right? And this speaker explained it really well. So I'm not gonna repeat that again, but it's the simple idea. The idea is you have to remember three things, which is linker. That's basically that's basically invokes your native function. Symbol lookups. That's the definition of your foreign function. And then arena is basically who owns the. If you are getting some memory, who owns this memory? Something like that. So it's pretty basic. I have a demo for that. And the benefit is that it's pure Java and type safe and memory is managed. You don't have to write any C code or anything. You can just invoke it. Now the question gets to be, when do we need it? Do we really need it? I mean, I have already told you, like, if you want to do some machine learning or something, you might want to use the established well-performed library that are already available. You want to use that. So over here, I have a simple benchmark that I'm going to show you, which is called matrix, multiplication. Simple matrix multiplications, we can do it using Java, no problem. Java can handle that. And but the problem is regular Java, if you are going to write it manually, it might be not that performance for a developer like us, especially me. But there is a library as well, which is a bit performant. But then if we can use like SIMD instruction or other native functionality, that would be way better. Why not we just use it? So that's what we're going to do over here. I'm going to run this and show you the demo. I'm going to discuss about this output, not the code. You can just get it. So over here, as you can see, the output is like if you are going to write the same things in naive Java, it takes like close 868 milliseconds. And there's a library that I have used called EasyML, which is optimized Java, but it's still Java. It's a library. It is 4.1x faster. But then if you are using native one, it's like way faster. Like you see the number. So sometimes we have a need for that. And for this purpose, sometimes people think about why not we use Rust or some other programming language for these particular features. But with the foreign function and memory API, we don't have to sort of use any other programming language. We can stay in our home ground, which is Java. That's we love. I don't know. What do you think about it? Personally, I'm really excited about that. Anyway, so I already have the demo. So now I'm going to focus on this basically 5 ideas. Sorry, four things. One is we have expressiveness. We have Kotlin-like records. We have Kotlin and Scala-like features, case class, records, pattern matching, all of those things. We have Scala-like still classes, which is closed hierarchy. We have switch, which is our pattern matching. We have Go-like, concurrency, which is virtual threads. We have Rust-like native interrupt, which is FM APIs. So we have pretty much covered all of them. So what do you think, as a modern programming language, if we have all of these things, do you think we can still consider this as a modern programming language, not some old, like, ancient programming language, even though they're old? Anyway, so that's the idea. Wait, but again, those features are basically visible. We get way more press, and then there are other features that are sort of hidden. They are doing a lot of interesting stuff. For example, compact headers. Now Java had every object had a header, right? And now it takes like 92 bits of memory, which is 12 bytes. Now they compacted it. It now takes 64 bits, which is 8 bytes. It doesn't feel a lot for if you just see it. But then if you have applications that creates millions of objects, even billions, it adds up. Even that means you will consume less heaps, and less heap means less GC. That means better performance. So in some statistics, they said it takes less, like 20% less memory, and it improves like performance by 10%, something like that. And there are some statistics around that you can look into. So there is another one, ahead of time class loadings and linking. So there is a concept called Java is slow startup, especially if you are running containers. It takes time to start. Now that also is getting solved by this. The idea is, when Java starts, it does a lot of things. It's linking, it's verifying. So you can do that. You can pre-compute all of those things and start faster with these features. And then, obviously, garbage collection is improving every day. You have stable values, which also going to improve your startup as well. So these are the features that you can just use it. You can, if you upgrade your Java version, you will pretty much get the first one, second one, and for the third one, which is garbage collection. For this two, you probably have to write code, but those are great. Those are giving you great benefits. So, these are the really interesting features you have available on your tool set. So just use it. So now the question is, why Java takes a long time to evolve? Okay, so first question, do you think Java evolved or not? What do you think about it? It did, right? Now the question, the following question is, why did it took so long? Why didn't it start, just start copying from another programming language, like many other programming languages does? This programming language has amazing features. How about we just copy it? The reason is that, obviously you know the reason, right? Java is used by, like we have a existing code base, millions of, billions of lines code base already written, and they are in a mission critical applications, banking, hospitals, and we definitely don't want to disturb them. So we have to produce something that's, enterprise rely on, people rely on. And let's forget about enterprise for a moment. As a developer, personally, when I'm investing a time on a programming language or a stack, I'm actually want to get some return out of it, right? I just don't want to learn a new language every other year. So let's say I have invested 2 years or 3 years, 5 years of my time on a programming language, and then I worked on it for a while, and for some reason I was distracted. I want to work something else, and I come back and see that this stack doesn't exist anymore. Or it's completely different, or it doesn't have backward compatibility with my existing stuff. That's a problematic, right? So we need that kind of stability. And also, first of all, could also read more than written. I think even though now AI is going to write a lot of code, but as a developer, we're going to read them a lot to review. So our role kind of shifted. We used to write code, now we are going to review those codes. That's our new role. So that's why readability, maintainability is extremely important. And then backward compatibility. When the new features are going to come to Java, the engineers, those who take decision, they care about that very much, because I want to shift a new feature, but I want to keep backward compatibility. It's utmost importance. I just don't want to break it. And that's the problem. I mean, some other community probably doesn't care about that much, but as a Java developer, I do care about that. My product is running, it's well. If I update my JDK version, it will boost my performance, but then it will break something else. That's kind of risk I don't want to take. With that, backward compatibility in stake, we don't have to worry about that. And also we have like world class tooling. We have tons of IDEs and all of those things. So that's why when you think holistically, when you are going to take decision, you have to be serious about it. You have to think through. So we cannot just jump, hope. This is an interesting feature. We can just copy it over here. Like in the first few slides, I've demonstrated that Scala has these features. Kotlin has these features. But when Java integrated it, it created in a way so that it feels natural to Java, right? Java developer can see it as a Java, not a completely new programming language. So we kind of have to have that feelings. So these are the reason why it takes times, but then it's available now. And basically my personal take is that it was a delivered evolution. It's not reaction by some other things, some other programming language when like Go has this particular features, Rust has this, but then we have everything over here in one ecosystem, one places, and I'm happy about that personally. So that's basically summarize the whole thing, whatever I have just presented to you. It has all these modern programming language features. It has advanced VM optimizations. It have lightweight concurrency that all we want. And if I need to work with native methods, native functionalities, we can use native interoperability with Project Panama. So yeah. So I think our old dog definitely learned some new tricks. Do you agree? Do you have an agreement over here? What do you think? So all right, so that's all I had. And if you want to take the slides, you can scan the QR code. And I have a giveaway, which is I'm going to do a lottery from here. And one lucky winner sort of can get it. So I'll give you 1 minute to sort of scan that QR code and fill up the form. It's like put your name, that's all. So, and I'm gonna take okay. So what I'm gonna do, okay, I have got, I'll take 1 more minute and I'll copy all this name. Just one, okay, so I'm seeing the timer over here. So I'll just take 1 more minute and then I'll draw. Hopefully, it will be fun. Okay, so this is a program that I have written like before this presentation, and I'm gonna copy all for your name. Hopefully this will work. And let's see. Okay, so yeah, 166 brave souls entered for this draw. Okay, let's see. It will take a bit of time. Okay, do you have Jonad Gracia San Martin? Do you have him here? Come on. Do you want to take a picture? Do you want to take a picture? You can come over here. So this is a new book that I have written recently, which is called Modern Concurrency in Java. It's all about the modern concurrency that I have just glossed over, like shared a little bit, but it has like all the depth in it. So if you are interested, you can.
Here.
All right. Come. Done.
I think I changed to video.
Oh, okay. Sorry about that. This one. Thank you.
Thank you.
All right, folks. Thank you for joining for this session.
hand and we'll run a mic over. Cool.
And you are on.
And I'm now on. Apparently I'm on. Excellent. Welcome everybody to the end of the day panel where you, the audience, this is audience participation time. I need you to start thinking of questions right now in your heads. I'm going to give you another 10 seconds to ask our esteemed panel here, who I will ask to introduce themselves shortly. And as they introduce themselves, you may pick up on an area of expertise or interest they have that you think, aha, I've always wanted to ask a question about that. So my name is Martijn Verburg, for those of you who missed me this morning. I'm also known as the diabolical developer, so I will be the rude person interrupting my esteemed guests if they talk too much. I think we'll just get started with a round of introductions to start with as people start filing in. So remember, your job is to think of questions, and we have 2 microphones down here from our lovely volunteers. Thank you both. So we'll pass the microphone to you so you can ask the question. Is that all clear? Did everyone understand my New Zealand accent? Perfecto. All right, love it. All right, well, I'll start to my left here. Please introduce yourself.
Hello everyone, my name is Guillaume. I work for Google, and for the past 3 years or so I've been focusing essentially on everything generative AI agents, etc. And I am also a contributor to some open source projects, including LongChain4j, and I'm not the only one on stage, as well as ADK for Java, Agent Development Kit. So I'm exploring all things agents in Java, because we don't necessarily need Python to do AI.
Correct.
Hi, my name is Mario. I'm from Italy, working for IBM, and nowadays mostly working as a contributor of LongChain4j. In particular, I'm developing the agentic module of LongChain4j, so I'm supposed to be an agents expert. In reality, I don't know. I have no clue what I'm doing while I'm doing it. Nobody else, I believe. And the reality is that I learn a lot from my mistakes, but I learn even more when I come to events like this. I talk to people and they exchange ideas, and this is why I'm here today as well.
Excellent. See, we're going to get honesty from this panel, people.
Hello, my name is Mihaela. I'm a software architect at Systematic. Mostly I'm building and designing software for defense. So my experience with AI at least will be covered by the fact that we work in an air-gapped environment, so we have certain constraints in working with AI. But I also have a PhD in artificial neural networks, so I've pretty much been attracted by this field for quite some time.
We have a genuine academic expert. Yes, at least one. At least one. Perfect.
Hello, my name is Pnuzal Machado. I'm a professor here at the University of Coimbra. I've been doing AI research in generative AI, I may say, since 1996, so 30 years now. It's quite a long time. I'm old. That's basically what it means. In fact, my thesis was called Artificial Intelligence and Art. And one of the questions was, why are you doing this? What's the purpose of that? Nobody cares about generating images with AI. So I got my revenge now.
Yeah. 30 years later.
I'm the director of the Center for Informatics and Systems of the University of Coimbra. And I guess I'm here to give you my opinion more as an academic.
Fantastic. All right, so we've got a couple of really strong practitioners, especially in the Java space, and a couple of very strong academic folks as well, which is a fantastic balance. So, did you all do your homework? Raise your hands. Who's got a question? Don't be shy. We talked about this morning. This is a human experience, which means you have to participate. Do I see a hand up somewhere? Yes, we have one. Fantastic. Thank you, sir.
Hello. What are your thoughts on the quality of code that agents produce when they start in a green field and when they already are working on a code base that already adheres to some of the standards and other such things?
Who wants to take that very easy question?
I'll try. Yeah, I think it has evolved a lot recently, honestly, in terms of quality. So in my experience, so I've worked with AI on greenfield projects as well as some existing open source projects with some conventions, etc. And if you teach the model to, or harness that you're using, to use reformat code and use that kind of style guide, etc., with agents, MD files, and so on, it helps follow along quite well. The thing that I'm still seeing, and I'm a bit bothered with that, is when our coding agents are trying things and not necessarily getting there in one shot, they still let some traces here and there, like unused classes that have been generated or things like that. And that annoys me a lot, and that still happens quite frequently. But otherwise, in terms of quality, both for greenfield projects and now, I think, for major kind of projects, it's been going on quite well.
Yeah, my experience is that these things worked better with greenfield projects. So when you start from scratch, this was the best thing that we did. But let's say from Opus 4.6 and let's say in February this year, this thing is going not incrementally, but in stairs. So we unlocked another step, I believe, around this February, and this thing started working very well also on existing project. And what I noticed is that not only it works pretty well, but it also, I believe I have a quite peculiar style of programming in Java, and probably all of us has. And this thing is also very often able to mimic my own code style. So I have a time distinguishing, okay, I know which part I wrote, which part has been generated, but otherwise I would have a time to distinguish the two things. This is really amazing on one side, scary on the other, probably, but yes, this is my experience.
So you have a colleague who actually agrees with you on tabs versus spaces for the first time in your career. This is good. Okay.
Well, if I were to speak from our experience in terms of quality of the code generated, I have to admit that we are still working on some very old legacy monolith infrastructure with plenty of dependencies and military operational flows. And it was extremely hard for us to teach AI and the agents and everything that we have used to adhere to our own rules, our own styling. And initially the code was of a very bad quality. I wouldn't have merged, never ever, the first initial stages of the code that were generated. Not to mention that when we tested the initial drafts for some prototypes, we had bad performance and a lot of security risks that were introduced. And in defense, we can't do that. So it took a lot of time until we have managed to train and get it used to our way of writing code. And we are still not at that level. So we are still writing ourselves mostly and just use AI to support and to make it more, to make the developer experience faster than previous, but not to actually replace our own work. So we don't merge code generated by AI yet. But we use it for prototypes. For that, it's okay in terms of quality. At least this is what we feel at the place I work.
Okay, interesting. Very different experience.
Really don't have much to add here. It's simply a little bit outside my expertise. My global feeling is that the AI tools that you are using today for coding and for most other purposes are still very limited. We are starting as the stone age of AI or something like that. So what we'll have in the future, near or long future, that's a different question, will be very different from this. As it stands today, and mostly my experience is working in the lab, where, come on, I don't care about code quality. Come on. The code is, provided it works on the lab, it's fine. And the quality of the code that we are getting from AI is, I'm going to phrase this very carefully, is not worse than the average quality of code produced by students. The average quality. Between the top and the low ones, there is a huge difference, as you know. But that would be my take. So I'm more interested in, okay, universities are slow. The University of Coimbra, in particular, is slow. That's why we are here for more than 700 years, because we are slow. That's not a bug. It's a different way of approaching things. So I'm really not that interested on where we are now. I'm interested on understanding where we are going. And if you are a teacher like myself, I'm also have to deal with the fact that we are training people that will be on the market for 20, 30, 40 years. So the questions we need to focus on are slightly different than the ones we have if you are on a startup and you have to ship tomorrow. So that's why my answer is a little bit biased.
Interesting, thank you. So lots of different experiences there. I think one thing that's come out of that a little bit is it really depends a lot on the training set that the models have been built on. And so I think when you're greenfielding, modern Python or JavaScript or something, you're going to see the LLMs doing a really good job of that. When the LLM has never seen an old legacy military application because it's not in the training set for very good reasons, you're going to struggle to build with it. Fantastic first question, by the way. So thank you for the person who gave that through. So now that the rest of you have seen what a good question looks like and it's no longer scary, who else has a great question for the panel? We have one in the front here, I think, hand just going up a little bit quicker, and then next over there, I think, afterwards. I'm going reverse order.
I wanted to know, in your experience of big organizations and others that you might know, do you let your coding agents do whatever they want to do, or do you have systems in place to limit what they can do? Like bubble wrap that you have in Code, that's one of the things. And if you have them, where do you put the limits of what they can do and what they are forbidden?
Excellent question. So we'll start in reverse order.
I can let them do whatever I want. I'm not shipping, so provided it's not on my computer, why not? There is no risk. So the question, again, doesn't really apply to my situation. In my experience, if I want a good result, I do have to impose some guardrails. So for instance, when we are working in certain domains with companies and so on, one of the biggest challenges is ensuring, for instance, that the large language model doesn't reply to certain questions and stuff like that. But not so much at the code development side of things. It's more about controlling generative AI, implementing guardrails, and so on and so forth, not at the code level.
Well, to this answer, I will answer with a very simple example. And think of this scenario. We have units on a battlefield and some resources. What will happen if some of the units need some resource reallocation, but your AI agent will decide to simply reallocate without considering all the facts? We wouldn't trust an AI agent to take this decision. So the answer in this case is that, at least for my organization, human in the loop is mandatory. So for us, an AI agent can retrieve all the data, make proposals, but it stops there. To actually implement changes, to do an update like the one I've mentioned, to move some resources to some units that are simply requiring them without a human, without a commander approval, that's a negative response. So to answer your question now with not this example, the AI agent stops at proposal. not in actually deciding or implementing the changes for us. At least this is what I can share from my experience so far.
Cool.
Yes, I will give you a different point of view because, yes, I work for IBM, as I said, but I mostly work on LangChain4j these days, which is an open source project. So it's not only what me and my other friends and contributor does, but what the entire community does. And it's impossible to say if pull request a contribution has been generated by a specific model, and to be, but I need to be in one of the gatekeeper, the maintainer. I need to check everything. Okay, there are people who I trust more, of course, people who I know less, but in a way or another, I have the problem that these days I'm overwhelmed of pull requests, and it happens quite often that people take an issue and ask, or 10 issues at the same time, and ask an LLM to generate 10 pull requests fixing that issue without even understanding what they are doing. And you often realize this because when you do the pull request review, you point at a specific line of code and ask why you did this thing here, and they have no clue. So that's becoming real a problem. So under a maintainer point of view of a relatively under the spot project is becoming more and more a problem. We are trying to set up let's say, automatic guardrails to stop completely generated pull requests, but they are very hard to detect, as you can imagine. So it's not only you in your, from my point of view, it's not only I and my team what I do, but what the entire community does, which is, of course, not under my control. The only thing that I can do is control what I want to bring in. But my problem now is that it takes half of my working time now. It's become very, time-consuming and cumbersome, yes.
So to speak about a big company like Google, so the last figure I've heard is that nowadays 75% of our code is AI generated somehow. That sounds like a big number. Not that I don't trust the number, but it's maybe we're accounting for things which are more tool generated sometimes than fully AI generated, or, well, anyway, I don't want to discuss the number in particular, but the thing, our own guardrails basically is that everything is reviewed by a human being. So the human being, and this is the case for open source contributions as well, the human review factor in time is the limiting factor, I think, for scaling the use of AI in development, right? And yeah, so yeah, that's the main point I wanted to make there.
Very cool. I'll quickly add to that inside Microsoft, it's a similar kind of challenge. I think that the human reviewer becomes the bottleneck, and it's something that I think the entire industry is looking at somehow improving, because there's a lot of strain on maintainers, especially for open source projects. And it is a burden. It's an emotional burden that makes you tired. I'm actually going to ask the audience a quick question here as a bit of a survey. Who here runs their Copilot or Claude or whatever tool you use in YOLO mode? How many of you let the agents just go mad? See, about 20% very brave people who hopefully don't work for insurance, health, or defense companies. And let me guess, is it the same people who run OpenClaw? Is anyone here running their own claw? OpenClaws? Oh, a very small set. Okay, so Portugal is still sane. That's good to know. Right, I think we had a question from a person over here. Yes, he's got his hand up just over there. If the next question can come from there. Wonderful. And we'll start with you this time.
Do you, or especially those of you who work in big tech, have access to some preview models, even like the most powerful models not yet released to public. And what do you think, like especially in relation to performance comparing to the models that are released to public and we had the opportunities to work with them?
Ooh, yeah, I think you'll probably, yeah.
So as I work for Google, yes, we do have access to models that haven't been released yet. We are always, using new models internally first to validate that they are okay, that there's no huge regression, that the tests and benchmarks and so on haven't really spotted. And what's weird is that we have like code names for some of those models. And especially when we're using internal tools for doing agent encoding, we can't necessarily use those outside. Like if I wanted to use them on LangChain4j or something, I couldn't really do that easily. But the fun thing, yeah, we have code names, and I'm not necessarily sure what am I testing. Like, is it a new Flash model, or is it something for coding? Is it something for, because sometimes we build different flavors of the same model for some specific tasks, and sometimes probably to do, how is it called, benchmarking, to be sure to be at the top of all the benchmarks. So yeah, we have access to those models. Not necessarily always super long in advance, but the thing is that when you have a big model, it's being trained like on a regular basis, and we take checkpoints, and we're testing a particular checkpoint of a model. So maybe that checkpoint will become an official frozen model, the one that will be available for everyone. Or, maybe it's going to be the next checkpoint that's going to be selected. We're not necessarily sure what's going to happen with each of them. But it's kind of funny to get the chance to use smarter or faster models. Yeah.
Yeah, even here I'm probably on the other side of the barricade, meaning that I don't have a preview access to specific model, but of course model comes out faster and faster. So and every time a model is out today, and people tomorrow or this evening are complaining because we don't support it yet in LangChain4j. So it's really a race to support them, understand how they work, integrate them. Okay, now we have a sort of standardized way. There is the OpenAI API that is used by most of these models, but from time to time you need to integrate. So this is to say that on my side, we are mostly a follower of what happens, but we need to follow very, very fast, and it's the first part of the first reason why I'm overwhelmed, as I said before, is for pull request. The second reason is because we need to provide support as fast as possible to newest models. So yeah.
I can continue, even though I'm not working in a big tech company that owns some models. But yes, we don't have access, at least to preview models or to models themselves. But this was actually one of the points that counted when we took the decision of which models to use. Because based on the infrastructure needs, air-gapped environment as mentioned, and due to some even regulation, some terms of services, we can't use closed models, those that we don't have access to, those that act like a black box for us, because we don't know what happens in there, and we don't know exactly where they are stored and where the information goes, and if something changed to those class models, we don't have access. Where in this critical line of fields that me and many other companies are working, this is a precondition, something that needs to happen. We need to have access to everything. We need to be able to audit everything and to be informed of what is being changed. And not only to be informed, but we need something that is constant, not that changes frequently, or not even of us being aware of the changes. And hence the decision, at least for us, was to work with open models, those that can even work in air-gapped environment. We don't need internet. We can run them locally on our own infrastructure. infrastructure, and we know each time what happens. And this was something that was a decision factor for us, the difference between the closed and open models. So this is from my point of view.
I also don't work in big tech, but let me give you a different answer. It's not about the model. In the end, it's not model A being better than model B or being marginally better at the benchmark that is going to make a decision or that is going to determine what's the best approach. In the end, it's all about the infrastructure, it's about the harness, it's about the tools you can build with the model, which is and all the ecosystem around. And the guys at Google can tell you about this. That's what's really going to make a difference in the long run. It's the same as computer languages and so on. It's not about the language, it's about everything that is built surrounding those languages. So that would be my take. Personally, staying at academia, I prefer to work with open source models, with open weights, and so on and so forth. But that's just because of the circumstance I met. But in the end, I do believe it's all about infrastructure.
Okay, cool. I'll add that, interestingly, people would have read about it in the media, etc., that when Anthropic released, or privately released, what they call their Mythos model, and they released it primarily to governments and large tech companies because they felt it was a security risk. Now, there are people who feel differently about this, but there was very much a case here where all of the large companies or governments had access to a model that the general public just simply did not. And that was actually by design to go patch a bunch of security holes in major open source projects and things. And there's still massive debates going on about the ethics and the morality of that, and if that's going to continue to happen. So something fun to debate with your friends later on. All right, you're doing exceptionally well, audience. I see a question right there, and then we've got more along the front here, loads of them in fact. I've got no idea who was first now, but we'll get started.
Hello. Just like Oliver question, will be the programming language matter in the near future, because AI wrote this code, and if you know some this architecture approaches and so on, and will be matter this program, in which programming language it will be written. Like next level of abstraction, we had machine code, after that assembler, now Java, and it's AI, it's next level of abstraction. Now we should learn programming language now.
So I think, yeah, maybe there's a future where programming language matters less, etc. But I think, pragmatically speaking, you should use a language that is already well understood by models. So programming languages like Java or Python as well, to my discomfort and displeasure, are languages that are well known and understood by LLMs because they've seen a lot of programs written with those languages in their training data. So that's why I would advise to stick to well-known ones.
My point of view is that, okay, of course I'm a Java guy, but I believe that, well, Java in particular, but all strongly typed language in general have an advantage over Python in this, because the LLM generate code and then it can compile it and use the type system to check what's going on and if it works. I mean, it's a first gate that you don't have with dynamically typed languages. So I believe that statically typed language have a big selling point in this, and because they are easily understandable and verifiable, but by the LLM itself. And this is something also related with the kind of work that I do now. For instance, I'm creating this agentic module, and I'm used to do TDD to check my API, if it's nice, if I like to use it, if people like to use it. But now I have one more step. I also try to figure out if the API that I create for my stuff is understandable for an LLM. So when I design an API, I also ask to the LLM, okay, this is my API, study it and try to use it to create a test or to do something. And in this way, I can understand if that API is also usable by an LLM. And in Java helps a lot with this. First, because it's statically typed, and then second, because it's a little bit more verbose, true. Not so true with modern Java, but let's say it's true. But we don't care about verbosity anymore, I believe, because now it's all generated. We care much more about understandability and readability, and these are historically winning point of the Java language.
Yeah, I think I also agree with what was said so far. I think it can work with any programming languages because it works on trained data, and I think any developers that need something in a certain language from C#, Java, Scala, Kotlin, JavaScript, TypeScript, and so on, will train the LLMs models and they will figure it out and learn, continues to learn, and so on. Obviously, the most frequently used programming language have more advantages because they are based on more trained data on that purpose. But I think it can work with everything, and I think that no matter with what we work with, it is important indeed, as my colleague said, to be readable by everyone, to be understandable, because if it generates a one line of code instead of 100 and you don't understand anything, well, it's like, yeah, where do we get? It's not something that we can easily understand.
Okay, I have a short and a long answer for that. I really don't think the language matters at all. There is a recent work, a large language model trained with data up until 1936, so before Python and before all programming languages, and it's still able to program in Python provided you give it enough context. Yeah, so that shows that Python is a basic language. That's one way to take it. I believe all the languages are, including human languages, not just computer languages, are more or less the same to some extent. But I think there are a couple of things that are very important. As my colleague said, we need to understand that nowadays the things that we are developing, the things that we are designing, can be a web page, it can be computer code, it can be whatever, are things that we are designing for humans and for AI. So you need to ensure that it's readable by a large language model and take that into consideration. And for instance, going back about the questions of what do you do with code produced by agents? Well, you just abstract. They can be human agents, they can be artificial agents, and you should treat them more or less in the same way, provided you need to have checks and bounds ensuring that the code is viable like you would have with human-made code. So that would be my take. In fact, this reminds me a lot a very old PhD thesis from a colleague of mine, which was called Hybrid Society, and it was basically about a society of agents. Well, this was in an artistic scenario with agents producing images and music. So the idea is you have an hybrid society with human agents, artificial agents, and so on. What are the sort of rules that you can develop to make sure that this society is healthy? How can you value the works made by other agents, and so on and so forth? Soon we'll have lots of these philosophical and practical questions rise up again, assuming that we are moving towards that. Also, and I know this is a long answer, assuming that we are in that direction, this is actually the hardest part of the job, because we are dealing with human and artificial agents performing the same tasks. It's not very difficult to have autonomous driving if you don't have human drivers on the road, or if you don't have humans at all. That would make it even easier. So this is particularly tough because we need to ensure that our code is readable, understandable, usable by humans and by machines. And this, I believe, is a very important concern to have nowadays. And for instance, I'm in academia. I publish papers. That's what I ship. I need to ensure that my paper is understandable by a large language model for many, many reasons, including if it's not going to be accepted nowadays. So we need to be aware of these things.
Thank you. One little addition from me is that we at Microsoft care a lot about the runtime, not necessarily about the language. So we have a lot of guidance about picking, where to use Rust, where to use Go, where to use Java, .NET, etc. That's our primary consideration these days. Okay, we have about 15 minutes left, if I'm being generous. So we're going to go a little bit more rapid fire now, so the answers are going to have to be a lot shorter. All right, I'll start with the gentleman in the green T-shirt down there to start with.
Hi. Do you think frameworks such as OpenStack or SpecKit can help us be more confident on the code that is generated? And when do you see that we'll have that trust and we won't need to review code anymore? Do you see it as a 1 year, 5 years, 10 years, something like that? Thank you.
So the second part of the question, I will not answer because I have no clue what will happen after the summer. So, and honestly, if somebody says he knows, he is a cheater. I mean, nobody knows, right? Okay, so I have no clue. About tools like SpecKit, I tried it. It really depends on your workflow and the task you are trying to do, the goal that you are trying to achieve. I mean, if you have clear in mind what you want to do, you have the step in mind, and maybe you have a well-designed features to implement. Yes, probably it works very well. Generally, this is a personal thing. Generally, this is not what I do. As I said, I'm experimenting a lot these days, not even knowing what I'm doing while I'm doing it. So putting this thing in spec, it probably will not help me a lot. The way I use the LLM is like a peer programmer. I ask it, I mean, I work with it incrementally, I try stuff, I ask it to suggest me a solution, and then I go through incremental refinement, okay? So it's not something, a spec that is written up front, it's something that I discover while I'm doing it. But I believe this is related with the kind of work that I'm doing these days.
Well, thank you. I'm actually going to change it up a little bit, just so we can get through the last questions. We'll just sort of have a question per speaker, kind of one-to-one thing until the very end. So I saw a whole bunch more questions up the front here. Down here, if the microphone can run all the way down here. And maybe if that can be passed over, or... Thank you so much for running. Getting the exercise in 30 degrees.
Right, thanks. I have a very kind of ethical question, maybe. So recently I saw an article saying that Cloudflare re-implemented Next.js by looking at their tests. And I wanted to ask you, what do you think this means for open source in the future, and so on? Will people start hiding their implementation? Maybe companies don't want their IP to be, let's say, stolen in between codes by AI models that can re-implement it. So then the people re-implementing it are not liable, right? Because you do that. So what do you think about the future of open source in this world of being able to copy stuff very fast?
Yeah, I think there will likely be different kind of open source projects as well. Open source project that will be like almost fully generated or replicating an existing framework for different reasons. I'm not necessarily too worried about this. So like in any ecosystem, the fittest survive and so on. But there will obviously be an impact there, and but the thing as well is just like Mario was mentioning as well, like when you experiment with things, it's also great to be able to have that liberty of taking an agent and try a new implementation of something. So just last Friday. So last week, Google released new products in the anti-gravity series of products. And there's an anti-gravity SDK. It's wrapping a Go binary, but it's the SDK is in Python. I'm a Java developer. What did I do? I spent 5 or 6 hours with anti-gravity CLI to what's the word? Retro engineer the actual framework to do it in Java, so that I could have the SDK call my Java code, etc. And that was a great experiment, and I'm going to release it as open source. And I was happy with that experiment, and I find it useful. Will it be maintained in the long run, etc.? Maybe not, but it's interesting to have that possibility.
Thank you. All right, we have 5 minutes left, folks. I see someone in an orange T-shirt directly. Oh, right there, I think in the middle. Perfect.
Okay, so you were speaking some moments ago about the models, the different models that you have. How do you, your daily work, choose the best model to use? So in our company, sometimes we try to manage costs between the result that you have. So how do you, your daily jobs, choose the best one?
Test. I can start on this one. For us, it's not the number of tokens, the answer on how we choose an LLM. For us, is something that can answer a couple of questions. Can I run it locally? Can my code stay safe on my local environment where I'm actually running that LLM model? Can it work in an air-gapped environment because we don't have internet connectivity? And also if it follows all the terms of services rules, because some of the closed models, for example, have strict regulation that cannot be used in certain domains like defense. So even if we would have wanted to use such LLMs, we can't. So these are some of the constraints that sort of forcing us to choose some of the models. At least this is from my experience so far.
Thank you. All right, I think we're down to just about the last question. Here we go. Perfect.
Hi. So sorry to pivot this in a different direction, but last year here at JNation there was a lot of emphasis in efficiency, in green technologies, in all of that. You see where this is going, right? And it's unfortunate that we can get all 4 opinions, because I think we have a really good panel here representing different spheres of society, right? We have company, private sector, we have the military, we have academia. But so how do you see that each of these sectors should, or what's the responsibility on each of these sectors in dealing with the issues being raised with the use of LLMs, both at the personal level and, I mean, mainly at like company level and state level and all of this?
I think it's actually a great final question, so I think we will give the panel, everyone, a chance to answer, but if I can ask everyone to keep their remarks to a minute or less each, I think we'll start at the end there.
For us, it's not a problem at all. We don't have enough money to destroy the environment. Well, now more serious. Well, that was also serious. I don't know. As I said, I've been working on AI for 30 years. So now whenever I go to my computer or open the news or anything, I see AI everywhere. It's quite overwhelming. It's quite stressful. And I may tell you that this was not the idea. The idea was not to build these hugely sophisticated models to generate AI slop or to put data centers in space. I'm sorry, it wasn't this at all. So I'm obviously concerned. For a very long time, we kind of assumed that this magnitude could not be reached because it wasn't sustainable from an energetic perspective. Current hardware is extremely inefficient when compared with human brain. For instance, your brain consumes 30 watts or something like that. So it's very, very small compared with any GPU. It turns out the solution is to just give more power. I wasn't expecting that at all. So what we can do, and what we have been doing in my lab, for instance, is to try to find more adequate uses of AI. First of all, not all AI, large language models are a very small part of AI. Not all AI is a large language models, and many AI techniques are quite cost effective. They are quite green, if you want to put it like that. Then, if you are working in academia and in Portugal, you need to understand we are not going to compete with Google. Come on, we don't have the compute to do that. So, and we don't want to. That's not our role in society at all. So what we are doing is we are focusing our research on things that are very relevant to us nowadays and in the future. That means sustainable AI, green AI, trustworthy AI, and so on and so forth. Of course, we don't control the adoption of AI. That's totally beyond our control of any of us, I believe. So at that scale, I don't have any answer. What I do believe is that there are many green, I hate the term, but I'm going to use it, is there are many green AI alternatives. And for instance, startups often come to us, and nowadays everybody wants to run a large language model, even for situations that it's simply absurd to run a large language model. There was one in particular that the problem could be solved with a menu with 4 buttons. That's it. And that was the best solution. But they still wanted to use a large language model because it was fashionable. So hopefully that will go away when it becomes less fashionable. And we probably will actually see a decrease, not in the use of AI, but on the use of this type of AI. At the same time, we have incredible progress on the efficiency of training and inference. So we can also reduce the costs a little bit there. And then there are many other solutions to reduce the cost. But don't worry, we don't need to focus on that because all the big players are focusing on that because it's a large portion of their money. So again, we need to know our place in society.
We're actually at time, and given that we want to respect everyone's time and also to respect our panelists here who represent some pretty sensitive companies and industries when it comes to this particular question, I recommend you find them after this panel and speak to them one-to-one, and they can possibly be a little bit more transparent than they can in a recorded panel situation. I know I'm feeling my media training coming over me right now. My lawyer's looming over the back of me. You probably feel very much the same way, I'm sure. So thank you for the wonderful questions, everyone. And if everyone could please give a round of applause to our amazing panelists. And yeah, please do come find us at the after this or at the after party, and I hope you have the rest of a great evening.